That's my normal these days. Oh, David left. He'll be back.
Yeah.
Hey, David. Hey, Scott. Hey, Don.
Good to see
Hey,
you.
everybody.
Howdy.
Hello.
Howdy.
We're at it once again here, eh?
Yes.
We are.
Good.
We have to keep Scott out of trouble on Tuesday nights, right? That's
You
that's
have
the
to
I am
rowdy
visit.
nights.
notorious for ripping up the town on Tuesday nights. That's the reason why we do Global Star Party at that time.
We're
That's what
appointed
Dobie told me in
Keeps me
commissioners.
out of
confidence.
jail. Keeps me. That's right.
And David is repping his McGill sweatshirt very nicely.
Yeah, I'm trying to get rid of this thing that suddenly appeared.
I'm just wondering, Scott, the cosmic fossils wasn't a dig at all of us, right?
Actually, I kept thinking of that, going, yeah, we are. We're kind of like cosmic fossils ourselves. And, I've been really kind of focused on the atoms that we're built out of, and how old they are and how long they'll last after we pass through you know, our door here. So
Hello,
they're
Kareem.
around. They're around for the
Hello,
long haul.
David.
Some of them are 13 billion years old.
Dang,
The
Hi,
hydrogen
my name
and
is Judy
helium.
Rackison.
that makes
I'm the
us
Deputy
older than
Project
dirt.
Scientist on the Fermi Gamma Ray Space Telescope. I'm here today to watch a video with you of 14 years of observations collected by the Fermi Large Area Telescope, or the LAT. This is the primary instrument on the Fermi mission, and it surveys the entire sky every few hours. This allows it to do a lot of really cool things. It can look at sources that vary on timescales from a fraction of a second to years on end. There are two different kinds of maps that we're going to look at. One map is in galactic coordinates. That means that there's a thin band across the middle of the image, and that's the Milky Way. You've probably seen images of the Milky Way in the optical. The Milky Way in the gamma rays looks kind of similar, except we're looking at a number of different types of objects. We'll also look at the gamma ray sky from another perspective where we're looking up and down out of the galaxy, which gives us a much better view of the extragalactic sky and all the sources way outside our galaxy in the distant universe. In this map of the gamma ray sky, where we have blue and red and yellow tones, what we're seeing are actually intensity maps. Fermi isn't an imaging instrument like you think of Hubble or Webb. What it is it's actually a photon collecting instrument. It's a particle detector in space. And we make these maps by adding up all of the photons we collect. In this case, these are over 4 days. The color scheme, blue, red, yellow, this is just a way for us to visualize it, because our eyes don't see gamma rays. Those circular sources that you see in the galactic plane are actually individual objects. Most of those are pulsars. These are rapidly spinning, dense stellar remnants called neutron stars that are actually varying, pulsing on timescales from hundreds of times per second to several seconds. We see sources above and below the galactic plane. Those are largely blazars. What that is a supermassive black hole, millions to billions of times the mass of our sun, the center of a galaxy, that is active. That means that there's gas and stars falling into it, and it produces jets of emission, and they're very chaotic systems. So they're turning on and they're turning off, and that's actually the source of a lot of the variability that we'll see throughout this movie. We have a team of dedicated scientists, what we call the flare advocates. Their job is to look at data every day that comes from Fermi and look for these flaring sources. It's not just so that we know that they're there and that we catalog them, but some sources are interesting enough that we want to tell our friends, other space and ground-based telescopes, that they should go look at the same place and collect multi-wavelength data so that we can better understand these outbursts. You might notice that there are a few odd discontinuities in these images. This is a result of holes in the data that we didn't want to be distracting, so we patched those images using frames before or after. If you look carefully, you see one source that isn't like the others. It's actually moving, and sometimes it gets brighter or fainter. That's actually just the sun. The sun is an interesting source in the gamma rays. It's not the brightest source in the sky like it is in the optical, but it's prominent in its quiescent state, where we're just seeing cosmic rays interacting with the solar atmosphere. We also see it when there are solar flares. That bright flash right there was a spectacular solar flare. You may have noticed a lot of variations in the sky over time. It's not the galaxy itself is getting brighter or fainter. It's that as Fermi surveys the sky, it doesn't do it completely evenly. Over many years, we accumulate a very nice, even exposure of the sky. But when we look at short timescales, what we're seeing are variations in the survey, not actual variations in the sky. But when you do see individual sources, those are real variations from our own solar system out to the distant universe. The sky exposure pattern seems to change a bit starting about 2018. This was due to a hardware issue where one of our solar panels stopped rotating. It's still fully functional and Fermi has enough power to operate both instruments and the observatory. What it means, though, is that the way we observe the sky and the timescales in which we survey have changed a bit. In our 14-year map, there's over 7,000 total sources. Almost 4,000 of those are these active galaxies, these blazars. There's several hundred pulsars, and in total, something like 2,000 of these sources are variable. This video showing the first 14 years of Fermi observations is just the beginning. Fermi continues to observe the dynamic sky every day, and we hope it'll continue to do so for many years into the future.
Well, hello everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and I have my co-host here, David Levy. Let's bring him on. David, it's been quite a week of crazy weather across the country. We had snow, we had rain, we had freezing rain, but we've also had some clear nights, and I've been out every night that I could just to look up at the stars, look up at the moon, and just kind of reconnect. And I was recently in Arizona as well. And later, not during this Global Star Party, but later, we'll be talking about a new project where we hope to have a astrophotography or astroimaging learning center in one of the darkest sites in the country, which is close to Portal, Arizona, and Rodeo, New Mexico. So if you're looking down at your maps, your dark sky maps, you'll see that it is inky, inky dark. So dark that if you look down at your feet during a new moon, you won't see them. So, but how did your week go, David?
Well, it was pretty good. I'm going up and down, Sometimes missing Wendy a lot more than others, and this was one of the weeks that I was missing her a lot. But I'm doing a lot better right now. And I wanted to say that I can't remember what I wanted to say, but here's what I wanted to say, that the weather here is finally going to be very cold. Like the temperature tonight is scheduled to go down to 50 degrees Fahrenheit. So we don't know what we're going to do. I went to university sweaters and chose this one from McGill. And so I had to wear my university sweater because it's going to get down to 50 tonight.
Oh, man.
It's
teeth-chattering cold in Arizona.
Oh, yeah. They're going to close the city down, and we're all going to lie down outside and look up at the night sky.
Yeah, that's right.
Anyway, I have something to quote from you today.
Wonderful.
Number of years ago, I was talking with my good friend Peter Jedicke, who sometimes comes to this Global Star Party. And I was telling him we were looking at Andromeda Galaxy, and I'm saying that we're looking at it as it appeared when humanity really was just starting to appear on the planet Earth. And he said, oh, no. We're looking at it because, and he goes into this light-like paths of light. As they leave the galaxy, they're going at the speed of light, so time stops. And anyway, Peter's probably right, but I still told him, I said, I think you're full of it. But anyway, I have here today a quotation from, of all people, Edgar Allan Poe, who wrote some very, very famous poetry and prose in the 19th century. And one of them, his most famous one, was probably the poem, The Raven. Quote the raven nevermore, that I think we're all familiar with. But the quote that I'm going to read today is a little bit different. It is from Eureka, a prose poem that he wrote in 1848. It was the last thing he wrote before he died. And it's kind of an interesting thing because Poe decided to get a little bit into science. And the way he did that was that he predicted by more than a century the successful resolution of Olbers' paradox. Olbers' paradox is a very interesting thing. Essentially, it says the night sky is dark, therefore life is possible. And he goes on to say that, there are 20 first magnitude stars in the sky spread about. There are several hundred second magnitude stars, several thousand third, hundreds of thousands and fourth. And by the time you get to 6, you've got millions of them. And then by the time you get to 8th and 9th and 10th, down to 21st magnitude, you get pretty much an infinity of stars, so much that no matter where you're looking up in the sky, your eyes are going to hit the surface of a star somewhere, which means the night sky is so bright that every square inch of it is as bright as the sun. And you go outside and you look up and you die instantly, and life is not possible. That's not true. You go out at night, you look up, the night sky relates to our theme about cosmic fossils this week, is dark. And why is that? And this brings to my quote from Eureka, a prose poem. And Scotty, you gave me a telescope years ago, which I prize like almost nothing else. And I named that Eureka. I named the telescope Eureka. I thought I was naming it after Archimedes' expression, after he's sitting in the bathtub washing himself, and he plays around with a little boat, and he discovers while he's in the bathtub the principle of flotation, a principle of flotation that he's been working on for years, and he suddenly realizes it. He jumps out of the bathtub and runs outside. According to the story, he didn't bother to dry himself off or put on any clothes, but in times, I think that was okay back then. Anyway, that's what I thought I was naming it after until today. I'm naming it after Edgar Poe's wonderful article, Eureka, a prose poem. No astronomical fallacy is more untenable, and none has been more pertinaciously adhered to than that of the absolute illimitation of the universe of stars. The reasons for limitation, as I've already assigned them a priori, seem to me unanswerable. But not to speak of these, observation assures us that there is, in numerous directions around us, certainly, if not in all, a positive limit, or at the very least, affords us no basis whatever for thinking otherwise. Were the succession of stars endless, then the background of the sky would present us a uniform luminosity, like that displayed by the galaxy, since there could be absolutely no point in all that background at which would not exist a star. The only mode, therefore, in which, under such a state of affairs, we could comprehend the voids which our telescopes find in innumerable directions would be by supposing the distance of the invisible background is so immense that no ray from it has yet been able to reach us at all. That this may be so, who shall venture to deny? I maintain simply that we have not even the shadow of a reason for believing that it is so. And he let it go at that. Back in the 19th century, he was ridiculed for what he wrote. He sent it to Astronomy magazine, and Dave Eicher totally
Tore it up.
Ever. Don't you ever. He sent it to Kareem, and Kareem said, "Oh, you can't say
Put it
that."
in the round file.
And that was back when I was young.
He sent it to Alexei, and Alexei said, "No way. I'm going to talk in Montreal." And there's no way. And they all shunned him. And they said, "Go away and get some Kool-Aid or something and
Yeah,
relax.
start drinking the Kool-Aid. Exactly.
You're not a scientist." It turns out that Edgar Poe was right. And we now know that the resolution of Olbers' paradox is that some of the objects in the universe are so distant. In fact, most of the objects in the universe are so distant that their light has not had a chance to reach us yet. And I wanted to share this wonderful quotation, Eureka, a prose poem, written in 1848, with you. Thank you, Scotty, and back to you.
Thank you, David. Thank you. So before we get started, of course, our next speaker is none other than David Eicher. But we should talk maybe just a minute or two about this effect of the further away we look, the further back into time that we see. And when I was putting together the theme of cosmic fossils, of course, I thought of, oh yeah, now I'm this year I'll be 65 years old, and I have become a cosmic fossil myself. but and you look at ourselves atomically, and I was asking Mr. Eicher here just how old our atoms are. And if I got it right, David, most of our atoms in our body are hydrogen, right? Is that
Very
true?
plentiful, and hydrogen, helium, and lithium and deuterium are very old. The Big Bang nucleosynthesis produced those in the early days of the cosmos. And of course, what astronomers and physicists call metals, all the heavier atoms, came later from the deaths, essentially mostly all from the deaths of low mass and high mass stars. So more recently, but still a lot of them, first generations go back a long way. So we're literally made of really old stuff.
Right. So we inherit ancient stuff to begin with. And I guess, a lot of people think that, okay, when we die, that might be the end of us, right? Okay. But it's not. Our atoms continue on, right?
The universe is the greatest recycling program that has ever will existed. Yeah.
That's right. I'm not saying don't go outside and pick up the litter around your home or off the side of the streets, or try to have less air pollution or something. But guess what?
But
at one time it's all going to recycle into something else, right?
That's right. But they've never been in such magical combinations until our lifetimes as the Scott Robertson, David Levy's, and the rest of us here in the world. Maybe not me, but you guys.
Well, of course
So that's a magic combination that we've never had, even if we have atoms that have been around for a long while comprising us. Yeah, 7 octillion atoms. That's a lot of atoms.
That's a lot of atoms.
Yeah.
So I asked our friend who comes on to Global Star Party sometimes about, if you took all those octillion atoms and you placed them one by one atom wide, how far would it stretch? And he actually calculated it because he took the proportions of atoms that are in the average human body. And he said that this thin line, which you couldn't see because it's only one atom wide, okay, would stretch 3/4 of the distance from here to the moon. It's a lot of atoms.
It's a lot of
teeny
atoms.
tiny little things. So
yeah.
But you've got your next talk here is something I'm really interested in because here in Arkansas we are amongst some battlefields from the Civil War, and your talk is astronomy in the Civil War. So I'm keenly interested in this topic. So,
well, thank you, Scott. Prairie Grove is one that comes to mind, but they're
and it's
in Arkansas,
right around the corner from us. Yeah,
yeah, indeed. And I apologize because I have had a really chaotic week. Trying to get things ready to go to Tucson on Thursday, where we'll have a Star Party event coming up this weekend. But it's been a crazy week, and I thought I had a presentation ready with a deep sky object, and I got home and I didn't, and I had to run around. So I have a talk that a couple of history groups asked me to do. So I figured, well, I might as well write a story in astronomy about this, astronomy in the Civil War. So I'll give a part of that tonight so I don't go too long.
Okay, all right. So I'll give you the stage here.
Thank you
very much.
Let me share the screen, and I'll see if I can share the correct slide. And if you're seeing it, and then I'll see if I can start a slideshow.
Yep. I see it. Not in presentation mode yet, but.
Are we there now?
Yep.
Yes.
We've got a presentation mode?
Yes, sir.
So this is a little bit different than what I intended, and with apologies, but we'll see where this goes. And Scott, if I go too long here, I'm trying to cut this in half, but if this is going too long, just tell me to shut up. Okay. and
We'll
all.
bring out that cane that they pull people off
Yeah,
stage
yeah, yeah,
with,
yeah, with around the neck. Yeah,
Just yank you
vaudeville.
off.
Yeah, 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 yeah. Mhm. So anyway, this is kind of an intersect. Oh, sorry, David. What?
Said we are not going to do that. We
Okay.
really,
We're not going. Okay, all right.
You know,
Darn it.
if you watch the great documentary about Buster Keaton, who got his start in vaudeville, as a child, and his parents, they put a handle into his clothes on his back so they could throw him across the stage when he was 4 years old, and he would slam into things. And that's why they called him, that was called, back when he was a child, taking a buster. And that's how he got his nickname.
Wow.
So next time you see me, if you don't like this, you can throw me across the stage. So anyway, this is kind of the intersection of a couple of areas. When I was young and working on the magazine, I got a whole bunch of stuff from a great-great-grandfather given to me who fought for Ulysses Grant and William Tecumseh Sherman in the Union Army during the American Civil War. And so I kind of got going in some history as well as astronomy. And I thought I'd talk about the intersection, a couple of spots in these talks, a couple of them here. I'll split it in two, I hope, of the intersection where astronomy and the Civil War meet. So this is kind of a Civil War era painting that's very famous in the Smithsonian collection of a prominent aurora by Frederick Church that was painted near the end of the war here as a kind of a scene setter. And I'll talk a little bit, forgive me if you know this, but I had to produce this for some astronomy clubs locally here, and also so I didn't know, how much people knew about the Civil War. So let me just review a couple of basic things. This was, of course, by far the bloodiest conflict in our history in the United States. More than 623,000 were killed after 4 years on the battlefield. And many, many more, tens of thousands, of course, had their lifetime shortened from wounds in the years and decades that followed the end of the Civil War. It was fought in 10,000 places, from minor skirmishes to major pitched battles. The federal government termed it an armed insurrection against the government, not really a civil war, but a war of the rebellion of individuals who were representing states who took power and rebelled against the federal government, against the Constitution. They didn't recognize factions in the South as legitimate state governments. The strategy of the South was mostly to fight a defensive war and to hold out for time that would aid them, giving the high costs of war, both in men and material, to the North. For the Union, the strategy was to cut off the Confederacy from supplies, vanquish their armies, and also occupy enormous stretches of lands, transportation routes, and coastlines, railroads largely, as well as frequently being on the offensive. And anybody who's read about military history knows that, generally speaking, taking the offensive produces a lot more casualties than defending a ground. So that there were all those things that the Union had to accomplish that made the war a long and bloody one. Of course, as you may know, as it started, there were many people on both sides who thought this might be a contest of weeks, and it turned out to be much, much worse than that. Fort Sumter to Appomattox and the other surrenders that happened in the Trans-Mississippi and elsewhere lasted slightly more than 4 years. And the war coincided with an important period in science and astronomy in particular. The 1860s witnessed the birth of astrophysics, of measuring the physical properties of the cosmos for the first time, beginning in 1862 with spectroscopy. So the Civil War and astronomy really emerged in a few ways in crossroads during the same era. Well, one thing that was interesting to me is that on August 22nd, 1863, this was a few weeks after the twin Northern victories, which were a long time coming, of Gettysburg in Pennsylvania and the surrender of Vicksburg to Grant in Mississippi along the Mississippi River. Lincoln made a surprise visit to the old U.S. Naval Observatory. The U.S. Naval Observatory for a long, long time is now is the vice president's grounds on Massachusetts Avenue in Washington. This is the old Naval Observatory that existed at the time of the Civil War down in the area that was called Foggy Bottom near the Potomac. And this is about 2 blocks north of where the Lincoln Memorial is now. The building is still there, and you can visit it by special arrangement and permission. And for me, it was pretty special. I used to have a pal who was the chief historian at the Naval Observatory called Jan Herman, and he facilitated a visit. And the group there, Abraham Lincoln, one of his private secretaries, John Hay, and a young astronomer who was 33 at the time, Asaph Hall. 14 years after this visit, Asaph Hall discovered the 2 moons of Mars. But on this night, they climbed up a wooden ladder that's still there into the observatory dome and used the 9.6-inch refractor that was there to look at Arcturus and the moon and a few other things. And I'll tell you, in historical places, there's a sense you can really get of the molecular vibes of history. Climbing that same little wooden ladder that Lincoln climbed up is one of those places. Well, the Naval Observatory visit, as I mentioned, followed soon after Gettysburg and Vicksburg, where it seemed that the tide of war was beginning finally to turn toward the north. But of course, as we know, the war went on for 2 more very bloody years, much bloodier than the first 2 years, to bring it to a conclusion. This is from the Library of Congress collection. This is the old U.S. Naval Observatory as it appeared in Lincoln's time. This was taken about 1867 to 69. It's not known precisely. The imprint was Bell and Brothers in Washington. And there's a very prominent foreground horse who posed very nicely for this historic picture. And you can see the building and the dome are still there. Well, of course, as we know in the world of astronomy, comets going way back several thousand years in history often represented omens of good or of evil, depending on who you were and what you were interpreting, how optimistic or pessimistic you were. 2 bright comets appeared in the early months of the American Civil War. One of them was in 1861, the so-called Great War Comet, and here is in Vanity Fair, a very popular publication at the time, an illustration of the very old and very obese Winfield Scott, Lieutenant General, who was the senior general in command of the United States Army during most of the first year of the Civil War. He was around as a young officer victorious in the War of 1812, and so for 50 years was around as an important general, and he was commanding the U.S. Army in the early days of the Civil War until the problematic George McClellan came along. And you can see the tail of the comet here of Scott is made up of swords.
Oh, wow.
On May 13th, 1861, an observer in New South Wales, Australia, discovered what came to be called the Great Comet of 1861. By midsummer, the comet moved into the northern hemisphere, and according to astronomer Horace Tuttle, you may recognize his name attached to comets, sported a tail stretching 106 degrees long.
Wow.
So this was a remarkable tail, about the same length as we had with Yakataki back in the mid-1990s. And so it really caused a press sensation. It was an evening spectacle in the north and came to be called the War Comet. The editors of the Brooklyn Daily Eagle posed the question, what means this visit, peace or war? The Great Comet of 1861 faded during the week of the First Battle of Bull Run, the first major land battle, leading to vast speculation about the meaning, but comets were not done with the war. In 1862, Tuttle discovered another comet that would rise to significant brightness. Another astronomer you may have heard of, Lewis Swift, also spotted this comet. When that comet faded, many attached its significance one way or another to the just-fought Battle of Antietam. This was in September 1862. Decades later, astronomers would identify that comet, of course, as the source of the Perseid meteor shower. During the visibility of the Great Comet of 1861, Private Charles Johnson of the 9th New York Infantry recorded thoughts on the visitor in his diary. The comet is now tired of his visit to these regions of space, he penned, or disgusted, it may be, with the appearance of things on this side of the planet, for he is now leaving in seemingly greater haste than he came, with his tail between his legs, for the unknown regions out yonder. Here's a modern view of what came to be known as Comet Swift-Tuttle, progenitor of the Perseids, and the first identified around the time of the Battle of Antietam. Another major omen arrived at year's end in 1862, coincident with the Battle of Fredericksburg, which, as you might know, was a major fiasco for the Union under the incompetent Army commander, Major General Ambrose Burnside. This painting depicts the victorious commander at Fredericksburg, Confederate General Robert E. Lee, riding with his staff and a brilliant aurora blazing overhead, which appeared on the evening after the battle. The celebrated artillerist, Colonel Edward Porter Alexander, who would become famous as James Longstreet's chief of artillery at Gettysburg, recorded his thoughts on the unusual and brilliant show of auroral light. Cries of the wounded filled the icy air, and Alexander wrote, "A brilliant aurora illuminated the night and much facilitated the work upon the entrenchments." The light show, of course, was taken as an omen of victory by the Southerners, and many Yankees took it as a sign of doom. In the Confederacy's capital, the Richmond Daily Dispatch proposed that the light represented the blood of those martyrs who had offered their lives as a sacrifice to their native land. And I think what we'll do, Scott, is stop there, and I will do the second half. And if you don't know how the Civil War turned out, don't go looking into any books over the next week.
Okay.
Okay, but I'll do the second half next week, and there are some other intersections of astronomy and the Civil War to be discussed, but I don't want to go too long tonight.
Yep. We have John Ray is watching on Facebook, and he said, "Wonderful how history in general is entwined with astronomical history. Thanks for that perspective, David."
Indeed, and thank you. Thanks, John.
Yep.
That I would like to ask a question.
Yes.
And story. I really did enjoy this, and partly because I remember the time you were in Tucson, and you and Wendy and I were watching the movie Lincoln.
And with my father, John, we watched it there with you guys, and that was a very special night. And by the way, if you don't know this, I have nothing to do, no business connection with Steven Spielberg, but the movie Lincoln is extraordinarily accurately and brilliantly done as a film.
Yeah, I think so too. Anyway, I've told this story before, and I'm going to tell it tonight, but I'm going to end it with a question.
Okay.
It was 1862 when excuse me, sorry a second. It was 1862 when Hall was at the Naval Observatory, and he was in a terrible, dreadful mood. And as he was getting his telescope ready, he just was not, things were not going his way that day. And to add insult to injury, as he's getting his telescope ready, there's a pounding at the door. And he just blew it. He thought, this is it. I'm going to go downstairs and I'm going to open the door, and whoever it is, I'm going to punch him out and tell him to get away from me. And he goes stomping down the stairs, opens the door, and there, facing him, is President Lincoln. And Hall was going, was this the same night that that was my question to you.
Well, this was the visit that's famous that Lincoln made to the Naval Observatory, and is on record having observed a number of objects with Hall, was in August 1863, was about 6 weeks after Gettysburg and Vicksburg. And that's very well documented in a number of sources.
All right, I'm not sure if this is the same visit. I do know there was more than one visit
Yes,
to the Naval Observatory.
that's right.
And he just said, sir, I'm so sorry to interrupt you. I know you're very busy, but was just taking a walk. I'm really depressed. And everyone knew that Lincoln was subject to depression.
Indeed, he was.
And I just was hoping that I could drop by and take a look through your telescope. And Hall immediately invited him in. They had a wonderful time together. He asked intelligent questions. Hall did his best to answer. And as he's leaving, he looks back and, like a little boy, said, "Can I come back again?" "Mr. President, you're welcome here anytime." And he came back just a few nights later with Stanton, Secretary of War Stanton. But I was wondering if the famous night in 1863 was the same night as my 1862 story or not. So that
I think they were different nights, and I think Lincoln did make more than one visit and with different people at different times. Despite the fact that Lincoln was often melancholy, and he was self-educated, of course, from a very young age. But he was a brilliant and very interested guy in all sorts of intellectual subjects. He went down, he tested new innovations in firearms at the Navy Yard. He fired new weapons on the what's now the National Mall, between the Lincoln Memorial and the Washington Monument currently. He was intensely interested in history and politics and in science and in technology. So I think he made several visits. This one was very well documented. And the Naval Observatory was a very interesting institution at the time because the superintendent who blew out of town and became a Confederate naval officer was Matthew Fontaine Maury. So, just as with other institutions, the institution there lost quite a number of officers to the South, as the war commenced as well. So I'll have to look into that further, David, to see what documentation there is. And I know that Stanton who was not a funny, friendly, jokey guy, but a gruff guy who was very serious all the time. But he was also a smart guy. So we'll have to look into the documentation of those other visits. But I know you're right, and they did happen.
Okay, thanks, David. There is one other thing.
Yeah.
You did mention that one can get a tour of the Naval Observatory. I did get a tour, but more important than that, on July the 16th, 1994, I got to spend about 20 minutes with the resident of the Naval Observatory at that time, which was Vice President Al Gore.
Ooh, yeah.
We talked. It was in the East Room of the White House, and we talked for a long time. Not a word about politics. He wanted to talk about comets, about Shoemaker-Levy 9, our discovery of it, how we did it, what the story was, and he was kidding around a little bit, and but we were reluctant to do that with the Vice President of the United States, but we got into it, and it was something very, very special. I just wanted to share that with you, and now I will go back to you, David.
That's incredible, David. And of course, he's a smart guy and very interested in science as well. And the new Naval Observatory, which I've also been to, but not to the Vice President's house. But there you also have to specially arrange things because you have to make sure that your car is inspected going into those grounds there with, under body mirrors and everything so that you're not, working for some bad guys from another terroristic country. So both of the observatory components in Washington require special arrangements to get into. The old because it's really a closed museum, and the new because the Vice President's house stands on the grounds as well. Yeah. But what a great story and what a great opportunity you had there, David.
All right. That's right. I think that this was a really great talk, Mr. Eicher.
Well,
And I
thank
think
you,
our
Scott.
audience really enjoyed it. And so, I know that we'll get back to those 400 or 500 other objects that we're going to talk about later.
Oh yeah.
But this is a very, very interesting diversion.
Well, thank you. And
So
we've
thank
got
you.
Yeah,
we've got 1864 and 65 to go yet next week.
looking forward to it. I'm jumping in really quick because, from my point of view, I like the fact that even in astronomy, you're helping to preserve some history in a time where we're sort of trying to rewrite a few of these things, and
Right.
for whatever political reasons, which we definitely don't get into in this show, but I, for one, appreciate that this retelling of history, and mixing it with astronomy, I think was a very important thing. So I look forward
I
to
think so
hearing
too.
more.
Well, thank you,
Mr.
Adrian.
Eicher is recognized for his knowledge of the Civil War and all these historical areas. In fact, when he goes to, like, we were just at Alcon, and I know he made a trip to go see some historical Civil War sites. So,
Well, thank you, Adrian, and thanks, Scott. And the old adage of, if you forget history, you're doomed to repeat it. There's a lot of truth in that. And
yeah,
a lot of folks who are around today, all I'll say is, they're not all of them are presenting, the facts as they actually happened in American politics today. But we shouldn't go any farther than that.
Right. We'll carry on regardless.
Yeah, indeed.
Okay. All right. Well, thank you, David.
Thanks, guys.
Okay. Well, Mr. Levy, we have Don Knabb from the Astronomical League coming on next. Do you and Don know each other pretty well?
We have met online here.
We've met online, and I believe did we not meet in the Baton Rouge last summer?
No, I didn't make it last summer.
Well, I heard of you last summer. There was a lot of,
Probably heard about me from Terry Mann, I'll bet.
and it was all very positive, and I'm really, really glad that you're on with us today.
Yeah, I'd spent several days with Terry at StarQuest in Green Bank, West Virginia. So
Oh yeah, she
just a
loves
few
that
weeks
event.
before Alcon. So yeah, we had a lot of time with Terry. My wife and I spent time with her. So it's a great event.
Excellent. Well, thanks for coming on, and we look forward to your presentation tonight.
Okay. And I do want to say before I start to David Eicher, I read the article in Astronomy magazine that your presentation is based on. I enjoyed it very much. Thank you. All right, let me share my screen. And I'm going to talk about Messier 41. Okay, coming through okay?
Yep.
Okay. So Messier 41 is called the Little Beehive. And this is a picture from, I think this was taken at Kitt Peak. And when you look at Messier 41, it won't look like this in a typical backyard telescope because all these small points of light, all these stars or galaxies behind it, they're not going to show up in a backyard telescope. So it'll pop much more in your field of view than you see in this photograph. But this is an amazing photograph, shows many of the red giant stars that are in M41, the Little Beehive. So before I go, before I start, I want to mention, don't forget, Astronomical League convention is in July in Kansas City, and Terry Mann's coming on later. She might talk about it, and it's presented by Astronomical Society of Kansas City. So I don't think we have another AL Live set up yet, but we just had that last Friday. I don't have a date on that, but I'm sure Terry would know about that. So the Little Beehive, again, here's the this view is from Kitt Peak, Arizona. Amazing facility. If you've never been to Kitt Peak, put it on your bucket list. It is an incredible place to visit. I was there many years ago, but never forget it.
Yeah.
So star clusters, we're going to do just a moment on Astronomy 101, because maybe some of the people watching don't have the depth of knowledge that everyone does about star clusters. So talk about open clusters first, which is what M41 is, Messier 41 or M41, the little. There are really two types, open and globular. So M41 is an open cluster, and that's a group of a few thousand stars, and they are buddies in the sky. They are formed from the same giant molecular cloud, and they travel through the cosmos together. But they don't last very long. They will disperse typically, and they can only survive for, a few 100 million years. Sounds like a lot, but when you look at the age of the universe, that's only about 1%. 1% of the age of the universe. So they don't hang around too long. So this is my favorite summer or favorite winter open cluster, the Pleiades, which I talk about on the show in November. And then Ptolemy's cluster in Scorpius. This is my favorite summer open cluster, which of course the Pleiades is easily visible open to the naked eye. M7, Ptolemy's cluster, in a good sky, like at, say, Cherry Springs or sure in Arizona, you can see it naked eye. Most other places where there's any light pollution, you'll have to use binoculars or a telescope. But it is a beautiful cluster named for Ptolemy, who had first recorded it in history. Now we'll bring in the cosmic fossils. So globular clusters, they are a spheroidal or a sphere-shaped collection of stars. They're bound by gravity, and it can be tens of thousands to millions of stars in a stable, compact formation. So they are the true cosmic fossils. Some as old, they are the oldest objects in the galaxy, even the universe. They can be 10 billion years old, so that's only 3 billion years less than the age of the entire universe. And they include some of the oldest stars in the Milky Way. They typically surround the halo, the central halo of the Milky Way. So this time of the year, in the wintertime, in the northern hemisphere, we're looking out away from the center. Not going to see as many globs. But come summer, there's a lot of globs. And probably my favorite is M13, the Hercules cluster, the Great Globular Cluster in Hercules is called. It is a sight to behold in any telescope. So encourage you to look for that one come the summer. So a little history. Messier 41 is open cluster in Canis Major, the big dog. This is Orion's hunting pal, Canis Major. First recorded possibly by Aristotle. It's not very certain, not determined certainly that he saw this, but his writing suggests that he saw M41. But much more concrete, and of course this is Aristotle up top, but this fellow down below, Giovanni Battista Hodernea, he definitely recorded it in 1654. He's credited with the discovery of M41. So it lies about 4 degrees, almost exactly south of Sirius. Sirius is the brightest star in our sky. And actually, Sirius is more than twice as bright as the second brightest star. Partly because it is inherently a bright star, but also because it's only 7 light years away. So that's like your next door neighbor in the neighborhood. It's very close to us. So the cluster covers about an area the size of the full moon. And it's about 100 stars. And we could see the red giant in the Kitt Peak photo I showed earlier. Of course, Messier 41, where's that name come from? Charles Messier, of course, the famous comet hunter. He listed as number 41 in his catalog of objects that are like comets but are not comets. So these were his notes from 1765. It says, I have observed below Sirius and near the star a row of Canis Major, a star cluster. When examining it with a night refractor. Now, I don't know what a night refractor is. I've looked this up and tried to examine what a night refractor is. I can't find that out. But Messier had about 12 telescopes. He had, 7 refractors, one of which was 30 feet long. He had 5 reflectors. So he looked at it with his night refractor, whatever that was, and it appeared nebulous, like a gas cloud, a nebula in space. He must have then looked at it with another telescope because he says, instead, there is nothing but a cluster of small stars. So if anyone out there knows what a night refractor is, I would love to hear it. But I cannot find any evidence of what that actually means, what he quoted there.
Oh, I can give a possible simple answer. It's the refractor his number one refractor that he would grab at night. and he wouldn't use it in the day to spot anything. It was specifically for the night. I have a night pair of binoculars that I use for that.
Okay.
There may be another definition. I really don't
Yeah.
know, but
I just-
that was I
Yeah.
wanted to throw that in there.
Yeah, I'd never heard of that before, but thanks. Yeah.
If we are to believe Leslie Peltier, he claims in Starlight Nights that Messier did most of his work with a 2-inch diameter refractor. And if that was the night refractor, then it was a small, long refractor. But I can't confirm that, but it's possible.
And that way maybe a 2-inch wouldn't actually discriminate the individual stars. So it appeared just like a nebula. His favorite telescope was evidently one of his reflectors. I'm not sure which one, but he had a dozen different telescopes. So and it was an interesting quote, I thought. So how do we find it? How do we find M41? So any night you go out, look to the southeast, look up, and you're going to be confronted very quickly with Orion. Easy to see Orion with his belt stars, his holding up his club, and Betelgeuse, Rigel, and of course the famous Orion Nebula here. And this is one reason I'm writing about M41. You know, everyone writes about M42, the beautiful Orion Nebula, but there's other things in the sky this time of year. So I wrote about M41 this time. So all we do is drop down from Orion, find the brightest star in the sky, which is easy to find, and just below and to the right is M41. To observe it with you can observe it with binoculars or any telescope, really. It's a large cluster. Remember we said earlier it's about the size of the full moon. So you have to use the lowest magnification you have so you can get the cluster in your eyepiece. So for anyone who's new to astronomy, that would be the eyepiece with the highest number. Typically with a telescope, you've got a 25 or a 24 or something like that millimeter eyepiece. Use that one. That will give you the widest field of view. And once you're zoomed in on M41, you can go to higher magnification to look at the individual stars. It is quite bright, and in the dark sky you can see it naked eye. Not where I live here, west of Philadelphia, but in a dark sky you can see it naked eye, and it's a great target for urban skies. And you know, even with the moon, you can see it through your telescope. So it's a good target for an amateur astronomer. Why is it called the Little Beehive? Well, there's another cluster in the sky called the Beehive, and these images are from Stellarium planetarium software, and they are at the same magnification. So this is the Beehive in M44 in Cancer, and this is the Little Beehive. So it is a lot smaller than the official Beehive. That's why it's called the Little Beehive. Okay, so this is that's the end. I will stop my share, and that's the Little Beehive story.
Well, that's great. That's great. So,
Scott, if I can just mention to Dawn that I believe the Campini refractor might be the one that was the night refractor because it got rid of the chromatic aberration, and that was the one that was used to find a lot of the fainter of the night sky objects at that time.
oh wow. Huh.
It was also the one used by Cassini, I believe, to start to spot the smaller of Saturn's moons.
What aperture was this refractor?
Good
remember?
question. I can try to look it up. I was on Messier's history earlier.
Okay.
It's
So Messier got it from Cassini?
no, Messier had a Campini refractor of his own. It was
Campini. Uh-huh.
Campani, sorry, Campani. And
Campani.
it was it says the magnification was only 64 times, but that it got rid of the chromatic aberration so you could see more clearly details in the night sky.
Wow.
But it doesn't say what the aperture was, unfortunately.
What an advance, though. That's great.
Yeah, he had 14 telescopes he used, so I don't feel as bad about the ones that I have. I feel like I'm still behind Messier. I'm okay.
Well, you'll get there. You'll get there. Well, let's thank you very much, Dawn, and welcome back, Kareem. It's great to have you back on Global Star Party. So we'll be coming to you here momentarily. But up next is Dr. Daniel Barth. Let me see if he has logged on at this point. And I do not see Daniel Barr, so we are going to go ahead and jump to our next speaker here, which will be Ron Breacher. Ron, if you're available, why don't we have you go ahead and log in with your camera. He's probably getting a hot cocoa or something. I can see
Well,
that
he's
logged
over in Guelph, Ontario, so it's kind of cold there too.
in. Yeah, that's right. That's right. Well,
Hi there, Scott.
oh, there he is. There he is. He ran to his microphone. That's great.
I was watching upstairs with my wife. I thought there was another speaker before me.
There was, but apparently, occasionally people will run into a problem where they can't log in at the last minute there. So,
Oh, well,
but
I'm all set.
yeah, so you've been burning up the skies with all your beautiful astrophotographs that you keep sending me. I love them, and
Thank you.
but tonight you want to talk about fossil deep sky objects. Now, a
Yeah.
lot of us that do astronomy outreach, we do talk about this concept of, it's coined as look back time, with light traveling, 4.9 trillion miles a year, 186,000 miles a second. It is, it's hard to wrap your head around things, and it's hard to think about that. The further away something is, the further back into time that we're looking. I remind people though that if they're just standing right in front of me, that there's some space between us, and I'm seeing him and he's seeing me the briefest fraction of a second ago, but not in real time. Okay.
So let me expand on that and blow your
Okay.
mind a little bit. When you look back in time, when you look at an object, the object isn't two-dimensional, it's three-dimensional. So if you look at a galaxy like the Andromeda galaxy that's 100,000 light years across,
Mm-hmm.
you're not just looking back at one point in time. You're looking back at a whole span of 100,000 years in time as you look at that galaxy. The universe, I mean, it looks flat, but it's not.
But it's
Not
not.
all of those photons travel the same distance. I know, right? But that's not
But
what
I love this. I love these aspects about astronomy. When I first started, and I started being told about how far away things were, and how big things were, and how small we are, and all the rest of it. I went through these phases of feeling very, at first, very insignificant. Which is kind of the humbling aspect that, that I would say that if you become an astronomer or stargazer, these are things that you do experience. Did you go through something similar?
Yeah, I did, but I don't think I stopped there. Like the two extremes that I hear, the 2 points of view that I hear
Yeah,
are, number one, what you just said, I feel so insignificant.
right,
But then there's another aspect, it's kind of a glass half full thing, which is
right.
you're
That's
part
right.
of something really big. And if we're the only things in it, what a waste of space, right?
Yeah,
There's
that's true.
we're part of something really huge. And we're the only beings we know of that are watching it all unfold.
Right.
So
So far.
it's important. We have a role to play, I
Yeah,
think.
it's kind of almost a sacred thing in general, to think of it that way. And I would say that what a privilege it has been for humanity to do all of that. And and then you look at the rate of discovery and the rate of what we're learning it's going at a pretty fast clip right now.
And the accessibility, people have access to information like they never had before. Not that everybody avails themselves of that, but even if you were interested in the past, you might not have access to good information.
That's true.
Now it's at your fingertips. Anything
right.
you want to ask is at your fingertips.
That's right.
So,
And with guys like you, Ron, you can learn how to access it in ways that will blow your mind. If this is the first time for you to see Ron on Global Star Party, or the first time to actually see him, period, you're about to be amazed. His astrophotography is breathtaking, and he loves the sky as much as anyone I
crazy
know.
about the
And
sky.
so,
But
yeah.
clouds, too many clouds.
Well, this is something else I remind people. This is again that glass half full, half empty. I remind people that even the word universe just means everything. Okay, it doesn't start at the sky. Okay, it doesn't start at out there in space or something, as we tend to think out there in space. Because hey, guys, we're in here in space too. Okay. And the universe is contained within our body. It's active, it's alive, and it's all intertwined.
Well, my glass half full says, I hope that there's people around me that are getting fabulous new equipment, because we've got the cloud curse that usually comes with the gear.
That's true.
So we'll see. Anyway, I wish the best for them.
Yep. Well,
So-
thank you for coming on.
Oh, my pleasure. I always read your write-ups that you send out to the Global Star Party presenters. I always look for inspiration from that for what I'm going to talk
Oh,
about.
thank you, Ron. That's very
And
kind.
so well, it makes it easy for me, right? And it keeps me more or less on point. So I'm going to share my screen with you,
Okay.
and let's get to my presentation and start the slideshow.
There
So
you are.
you wrote all about fossils, cosmic fossils. And so I thought about that, and I thought about what are the categories of cosmic fossils. And my wife and I sat down and had a really good chin wag. I mean, I came up with a couple of obvious ones, but we expanded on that, and I have some cool stuff to share with you today. So first of all, let's talk about what is a fossil anyhow. And then I'm going to show you all the categories of cosmic fossils and give you some examples. And really, I just want to show you pretty pictures. We don't have to get too technical. I just love looking at these things. They are just so beautiful. This is a real rock fossil of an ancient snail. And it looks kind of like a galaxy, don't you think?
Yes.
So I started out by thinking about what a fossil is, because that helps me focus. And it's really a remnant of something very old. It doesn't actually have to be static, or in living terms, it doesn't have to be dead. All it has to be is a remnant of something really old. So a lot of the things I'm going to show you are still quote unquote alive. They're still dynamic systems. They're continuing to evolve in really interesting ways. So here's the categories that I thought of. And I said I thought of the easy ones: planetary nebula and supernova remnants. But through talking with Gail, we came up with a few others that I want to show you some examples of. And that includes comets, black holes, tektites and meteors, and some other cosmic visitors. And like I said, this is just a tiptoe through some pretty pictures. We have 15 minutes for these presentations, and I can get through plenty of photos in that time. So let's start out by looking at some planetary nebulae. And this is the Ring Nebula. Maybe you haven't seen it this way before. I did quite a lot of enhancement of the faint H alpha, hydrogen alpha shell around the outside. But at the very center, I think you can see my mouse, and I'm giving you a little highlight. At the very center, you can see a star. And that star is a white dwarf. And it is a remnant of a sun-like star that has basically used all of its fuel it's not big enough to explode in a supernova. And it's basically coughed off its shell of remaining gas, mostly hydrogen and oxygen. And the white dwarf is now causing that gas to glow. And over cosmic time, that white dwarf is going to gradually get cooler and cooler until it disappears into a cinder, and the nebula won't be visible anymore. It's just, we happen to be here at the right time. The hydrogen is red, and the teal colored gas is mostly oxygen. And this is another really famous deep sky object, the Dumbbell Nebula. And I was honored to actually have this photo. This was my first photo ever on the cover of Sky and Telescope. My only photo ever on the cover of Sky and Telescope so far. And again, there's a white dwarf at the very center of this nebula causing the gas to glow. This is a beautiful sight in an 8 or 10-inch telescope. You don't see the green parts, you see mostly the red parts, and it looks kind of like an apple core, is the way I would almost describe it. But it's just another gorgeous planetary nebula. And here's a couple of smaller, fainter planetaries that really show off their central star nicely. This is Jones-Emerson 1. And this image was made with hydrogen alpha and oxygen filters. Again, the hydrogen is the redder portion, oxygen is the greener portion. And you can see that central star that's illuminating the nebula. And eventually, when that star fades and dies, the nebula will go with it. And here is another beautiful planetary. This one is called Sharpless 2-290. It's a member of the Sharpless catalog of over 300 objects, faint nebulae in the sky. And this one is a little bit asymmetrical. The main star that's illuminating the nebula is not in the center. But again, you see that red on the outside, green on the inside of those small planetaries. Let's shift to supernova remnants. And I'm in the Northern Hemisphere, and I do not have a regular access to Southern Hemisphere data. So the supernova remnants that I'm most familiar with are in the Northern Hemisphere. And this is a part of the Veil Nebula Complex. And the Veil is massive. It's almost difficult to get it all into a single image. The best images that I've made of the Veil have been mosaics of multiple panels. But this is one part of the Veil, and here's another part of the Veil, which you can actually see is on a poster behind me that was used to advertise the camera and telescope that I was using at the time. And I told you I've shot a mosaic of this. Here's what the whole thing looks like. It is huge. I think it covers something like 6 widths of the full moon, and it extends both above and below the boundaries of this slide. Beautiful object. And again, in a moderately sized telescope, you can see all of the Veil. With a good oxygen 3 filter and a nice low power eyepiece, you can really get it. And this star, there's a star right here. That's 52 Cygni, and you can find that with your naked eye, so it's not too hard to locate the Veil. The Veil Nebula was exploded about 8,000 years ago. And so this is an 8,000-year-old fossil, and it's not being illuminated by a central star. Rather, these are basically glowing gas from pressure from the blast of the supernova blowing the gas out. And over time, as that shell gets bigger and more diffuse, the nebula will get fainter and fainter. So again, aren't we lucky to be here now at this point in time when we can see such a beautiful thing? Here's the other Northern Hemisphere supernova that's quite famous. It's called the Crab Nebula. And this one, the explosion of the supernova was actually observed in 1054. And it is much smaller right now than the Veil Nebula, but it is expanding. In a previous talk for a global star party, I showed a picture of this nebula from the 1950s, imaged by the Harvard Observatory, and you can really clearly see how it's expanded even in the last 50 years. The first pulsar that was ever identified is at the very center, the dimmer of these two stars, the dimmer of these two stars at the very center of this slide is that pulsar, the Crab Nebula pulsar. So it's spinning really, really quickly and sending a pulse of radio waves our way every time it does so. Very cool. And that's what's illuminating the Crab Nebula. Comets. Well, they're not really deep sky objects, but they're sure pretty deep from my point of view. And they come in from far away so that we can see them like this with a nice, beautiful tail up close and a nice expanded head. I imaged this from my driveway with the DSLR in 2023. This is Comet 2022 E3ZTF. I feel almost embarrassed talking about comets, given who we have hosting the show tonight.
Hey, comets are for everyone.
Comets are for everyone.
That's
And
right.
I may not be the best comet photographer, but boy, they are fun to shoot and challenging. You got to be at the right place at the right time. You got to have a clear horizon often. And, you know, comets move at a different speed than the background stars. So making a nice image with nice round stars and a beautiful comet is a technical challenge that I really enjoy. So this is
that's a beautiful shot though. Off to the left, you can see the plasma tail stretching away from the
there's
sun, and then
tail coming off
that
there.
curved yellowish dust, the big
Yeah.
wide swath is its
Yeah.
orbit around the sun. So
Yeah,
very cool.
yeah, thank you. And this was my first comet shot ever. I shot this, believe it or not, with an 11-inch Schmidt-Cassegrain telescope that was not polar aligned. Sorry, it was polar. No, it wasn't polar aligned. It was mounted on an alt-azimuth mount, so like a lazy Susan and tip
Wow.
up down, like a Dob.
Mm-hmm.
But it was a tracking mount. And so what I did is I shot a series of 10-second exposures and was able to make this image. So this is my very first comet shot, 7P Holmes. And I must have done this, it must have been around 2004 or so that I would have made this image. Okay, so black holes. I guess black holes are another kind of fossil, right? They're really, really old. They're a remnant of something
Maybe
else
the
in the
fossil.
past. But we can't, or at least I can't, take a picture of a black hole. But I can take a picture of the evidence of a black hole. So this is the Centaurus A galaxy. The data came generously from Martin Pugh and Steve Mastellato. And you can see these two little red hydrogen flares coming out of, well, they look like hydrogen, but they're not hydrogen. I guess they're plasma or gas that's being illuminated by X-rays that are being emitted by the black hole at the center of this galaxy. So how cool is that? That is really darn cool in my book.
It's a great shot.
When we were talking, Gail reminded me that we have a few samples of cosmic fossils in our own home. And these are a couple of pieces of desert glass from Libya, and they're tektites. And tektites are formed under the high heat and pressure of a big meteorite or comet impact. And so that reminded me, of course, that we also have some meteorites in the house. So this is a sample of an iron meteorite from Argentina. And so that's my little stroll through my cosmic fossil collection. I hope you've enjoyed it. And before we leave the cosmic fossils, let's not forget Oumuamua. This artist's impression and the orbital image both came from the Wikipedia page on this object. But that's another example of something that's really, really old. It's a remnant of something from some other place and time. And who knows, maybe we'll see something like it again. We can all be cosmic archaeologists. Anyway, I'll stop my share now and thank you all very much.
Thank you so much. That's great. Comments. Chris Larson is watching on YouTube, and Jeff Wise. They love your images.
Thank you.
Chris says, beautiful. Any comets currently available for small telescopes or DSLR? What do you think?
Oh yeah, there's always comets available. Just look them up. Look them up online. One good site you can look at is Telescopius,
Yeah.
and you can input information about your imaging system, and it'll help you identify targets. And I think comets are in there as well. The other thing you can do is I use the Sky X, and it has a comet ephemeris in it. That's what I use for acquisition. So lots of good information out there.
Awesome.
And check the magazines, Astronomy magazine.
Yeah, Astronomy magazine's a good source.
Right,
That's
so
right.
that you get plenty of notice with them too, because there's been a sort of a tendency to, or at least for me, to receive these magazines now well in advance, maybe a couple of months or 6 weeks before the month that they're writing about. And in the center of each of those magazines, there's a whole solar system guide. And if there's a good comet to be seen, they'll both be writing about it.
That's right. Behind me, you see some of the kind of next generation, what could be considered introductory telescopes. So some of these, especially the Unistellar that's behind me, is a telescope that's connected with a science team. Dr. Frank Marchus at SETI kind of heads up their citizen science program for that. I brought these behind me. We're now distributing all of these products for North America. And so we have this one right here, which is the dwarf, okay? Probably the least expensive one out of this whole line. And then we've got the Unistellar product. There's several models. And then Vianus, which is another really beautiful and stylish looking telescope. But you can get started in astrophotography with these. To do what Ron Breacher does, you need to step up to some better equipment, but this will get you started. So, yeah.
And now those photos that I showed you, I just want to be clear. So the Veil Nebula, for example, that was shot with a 4-inch refractor.
True.
Okay.
And you can do it with smaller apertures.
And that particular image was a mono camera, but I've shot the Veil with a 1-shot color camera too. And I mean, the equipment has really improved. I think it depends how much you want to be a driver and how much you want to tune the car, right?
Right.
So now equipment is starting to evolve to the point that you can be a Sunday driver. You can just enjoy going for a drive. You can enjoy how plush the seats are and how smooth the ride is.
That's true.
Right? But if you want to tune the car, if you want to get under the hood, if you want to see how far you can push it up a hill, you can do that. There's all kinds of options in terms of the equipment.
That's very true. Yeah. And, so a lot of us as amateur astronomers, we like to get our hands on the equipment and make the adjustments ourselves and stuff. But the point you're making, Ron, I was a little bit shocked when I first started being introduced to professional astronomers. Professional astronomers, most of them are not allowed to talk to mess with the big observatory telescopes. They have a technical team that does it, and if the investigator for that night has a special instrument package, they put it on. They make it work, and the job of the pro is to collect data, and to follow up on their program. So in this way, these kinds of telescopes are great data collectors for you, and they do a pretty remarkable job. And so I'm really impressed with them.
Yeah, and you don't even need to drive the telescope now.
No.
You can get great data from remote observatories. So
That's true. That's
we
also
have
true.
Masters of Pix Insight. We do workshops, and Telescope Live is one of our sponsors. They have all different kinds of sizes and shapes of telescopes all over the world, both hemispheres. If you've got 3 months of cloud like I have and you're itching to get a good data set, there's all kinds of outfits like that where you can do
Yeah.
that.
You
Or
don't
you
have to
can
wait.
just write to me and ask me. I've seen a starving astronomer before. I've been one, so I'll gladly throw you a data set if you just ask.
So what's the best way for people to reach you?
Well, let me share my screen one more
Okay.
time.
Okay.
I actually put that on a slide, but never showed it. Go to my website. That's a good place to start. It's astrodoc.ca, and you'll find all my images are there, and they're sorted by category of objects. So if you're looking for an example of a planetary nebula, you can find it there. I do one-on-one teaching and equipment support, so you can find how to reach me there. I've got pictures of all my equipment to give you ideas for how you can set stuff up, including dual scope setup, roll-off roof observatory, that type of thing. And all the articles I've written for all the magazines in North America and in Europe, they're all in here under articles. And there's more information here as well. So, go check out the website. Every photo that I post, I give a complete processing workflow. So I'll tell you about all the equipment, how much data was collected, and what I did with it to make the picture look the way it looks. So that's probably the best way to reach me, astrodoc.ca. If you want to reach me by email, it's at the bottom there, but I'll just read it out, rbrecher @rogers.com. That's the way to reach me.
Great. All right, Ron. Well, thank you very much, and we'll see you next time.
Thank you so much. Bye,
Take care.
everybody.
Thanks.
I wanted
Good night.
to add my thanks to Ron's wonderful presentation. And what I don't know about comets, what I do not know about comets could fill many, many books. So I'm really glad that you provided me with some of that tonight. Good presentation.
Thank you. Thank you. Thank you. See you later, guys.
That's great. Okay. All right, David, we have our next speaker is none other than Terry Mann. Both you and I know her well. And, Terry is a remarkable person that's been supporting our community for a long time. She's always seems to be full of energy and full of great ideas on how to take astronomy to the next level. Terry loves Aurora. We're going to have some Aurora images from Elixir later on tonight, which I'm sure she's going to watch. But the Astronomical League gives out many awards. I think I saw several of them on the walls of your home. Is that right, David?
Yes, there are a lot of Terry stuff that I have seen, that I've enjoyed, that I've hung here in my home, and Terry is just a wonderful, wonderful observer of the night sky. And I'd like to think that the sky itself feels richer, that Terry is one of its great observers.
I would agree with that. I would agree with that. So,
Thank you both. Yeah. I enjoy observing just like everybody else, I guess. So, yeah, but thank you both. That was very, very nice. So, it is such a pleasure to be here, kind of in a little bit different format. Tonight, I wanted to talk about the Astronomical League Awards, mainly because we have deadlines coming up and we have made a couple changes along the way that I wanted to get out here as soon as I can. So, let's see if I can't get there. We go. I wanted to give a quick update on the awards, what's coming up, what has been extended for any Astronomical League members that might be out there watching. These are all of the awards that will be presented in 2024 when we're in Kansas City. The first, 5 are youth awards. The NYAA, the NIA, is National Young Astronomer Award. Any youth that is below the age of 19, not in college yet, can apply for this award. And all of these, I can't go into detail because there's so much information for all of them. You can go to the Astronomical League website, and on the very front page, if you scroll down a little bit in the middle, there's this big oval and it says awards. You can go there and get all of the information that I won't have the time to give tonight for these awards. But the H. Parker and the H. O'Meara and the H. Smith and the H. Dioria is Horkheimer. Jack Horkheimer, when he passed away, the Horkheimer Charitable Organization had a certain amount of money that they funded or supported these awards. These will be coming to an end probably after 2024, possibly. The league is looking for sponsors for those awards, because the contract was he would do it for 10 years, and they've done it for 12. And after this year, that will leave these awards open, so we are looking for sponsors. But all of these deadlines, except the Horkheimer Parker, will end April 30th, because that is an imaging award. Now, the webmaster, which is the webmaster of your organization or a club, there is an award for league members there. That deadline is still March 30th. Mabel Stearns is a club newsletter or any type of newsletter. If the museum is a member of the league or whatever organization, and you send out the newsletter, you can have that entered for the Mabel Stearns. Sketching, again, that's pretty self-explanatory. And now we have the Fleming Award, which Explore Scientific does underwrite. And Fleming has been extended till April 30th, too, because both imaging awards, they wanted to extend past the April 8th solar eclipse. So those awards will be coming up, deadlines coming up in another, just about, you've got a couple of months. But we wanted to get a reminder out to everybody as early as we could. Now, let me talk a little bit about the Fleming. The Fleming is a new award, and we thank Scott and Explore Scientific for supporting that. It is for women astrophotographers of the league. It's just something that, you get a bunch of us women together and we can geek out just as much as all of you guys can too. So it's kind of funny when you get all of us together and talking. It is an award, as I said, for women. It has been extended until April 30th. And right here is when you're a woman that enters this competition, the very first time you enter, they will get this pin for the Wilhelmina Fleming, because she is the one that discovered the Horsehead Nebula. You will get that pin one time for entering the Fleming Award if you're a woman that's in the Astronomical League and an imager. And these are the categories that we may include. It will depend on entries, what we see. So there could be atmospheric phenomena, deep sky, solar system, and wide field, which all of that covers a wide variety of imaging. So all of that will be covered. All of these awards that you're seeing and hearing about, you will enter that. If you have any questions, once you read the page on the Astronomical League website, you'll see that they all have their own email address, and all of those will go to Chuck Allen, the vice president of the league, and he has judges that are judging all of these awards. So please just take a look at that and see what you think, and please enter before April 30th for the imaging, or if you're under the age of 19 for the Horkheimer Parker Award. And just take a look at that and see what you think. And I wanted to bring up Astronomical League Live. We will be back on February 16th with Bob King. And he's going to be talking about a comet, 12P Pons Brooks, the comet with a popcorn personality, because it has been so active. And you can watch it right here or on the Astronomical League Facebook page, YouTube. You can watch it about anywhere. Please check either the League Facebook page or any other of these, and you will see an announcement come up to remind you that Bob King will be joining us to talk a little bit about the comet. So I'm going to stop sharing there and go back. So that is it for me, Scott.
Well, that was short and sweet, but yeah.
Yeah,
but that's fantastic.
I just wanted to get out a reminder so everybody knew, what was coming up and what was extended.
I know that, and I feel that David Levy feels very strongly about this as well. That that the Astronomical League, I mean, with all the awards that you guys give out, you probably do more to recognize people for their achievements. And, of course, we all love being out looking at the sky and recording our data and doing a lot of things that are already, part of the observing programs that you guys have, which I think you guys have 80 or 85
we're
programs.
somewhere around there.
Always coming. But to be recognized for something, especially from such a prestigious and venerable organization that is the Astronomical League, with its 75-year history and, all the amazing characters that have been there to build that organization, to be recognized by that body is a huge highlight and something that I think that anyone would treasure,
The history
I know I treasure mine. So.
The history of the league really is amazing. Chuck Allen is working on a history page of all the leadership of the league, all the presidents through the years, and to finally to connect a face with the name and look at that, and you really realize how many years, the league has been around. But I tell you, with a little over 23,000 members, we have some incredible people out there. I mean, people that it is such a pleasure to recognize, such as David Levy, and so many others that we have recognized. These people are amazing. And it is so incredible to be able to sit down and talk to them and to meet with them. And the kids, look at the kids you have met and interviewed, even like in Albuquerque, Baton Rouge. These kids are amazing.
Wow. So smart.
Yeah.
So, scary smart, so it's great.
Unbelievably smart. If I would have thought in the way they did in school, oh my gosh, I was too busy worrying about, what else was going on in the world, not about studying. It is amazing. I have enjoyed every minute of it. You talk about how many people we've recognized. We are so lucky to have people that are so into this hobby and enjoy reaching out and sharing with other people. So it is incredible to be in this position and to be able to do things just like this and talk to everybody that I can't meet face to face with. These people all do a lot to bring astronomy to the community, and I think it's incredible. So it's a pleasure to be here.
Well put. I wish I'd recorded all that. Wait a minute, I did record all that, so so I might be using it in some of my future write-ups. Thank you, Terry.
Thank you, Scott.
Thank you so much. Okay. All right. Well, that's Terry Mann from the Astronomical League. So we had a double header today with two people on from the Astronomical League. Two executives from the league, but many of us actually belong to the league, and you can too. All you have to do is go to astroleague.org and become a member at large, or join up with a club that's already a league club, and there are several hundred of them, so they're not hard to find. Actually joining up with a local astronomy club that is an Astronomical League club is probably the best way and least expensive way to go as well. Anyhow, we were going to have a 10-minute break, but we're just going to keep on keeping on here on the Global Star Party. And we are going to introduce Professor Kareem Jafar. And Kareem is from Canada, like David is, where a lot of super great astronomers come from. And he is from the Royal Astronomical Society of Canada, the Montreal Center. And David, was this your club? I mean, were you from this club? You were president of this club, I think.
I was never president, but it's the club I started out with. October the 8th, 1960, I first walked into the observatory there, and the first person I met was Isabel Williamson, one of Canada's greatest astronomers. And we got to be real terrible enemies over the years. We repaired that, and we got to be very, very good friends over the years, for many, many years.
That's
anyway,
right.
Kareem is really following in the wonderful footsteps of history that the Montreal group has had. And I'm just so glad to be a part of it.
Yeah, that's right. So Kareem Jafar pretty well. I'll let you do the introduction.
Okay. Kareem is someone who has caught the spirit of amateur astronomy, caught the spirit of the sky. Not the science, yes. He's very good at that. He's a first-rate teacher. But as someone who can transmit his love and his passion for the night sky, I believe Kareem has no equal, including me. I think he has inspired so many people to inherit his passion for the night sky. It's really
Wow.
I would agree with all of that.
I don't know how I can go from that. That was amazing to read. Thank you.
David, this is probably the first time we've made Kareem almost speechless. So that's great. That's great. But you do deserve it all. And you are the astronomy educator that many of us wish that we had. So
I appreciate that, Scott. This term, I'm not getting to teach astronomy at the campus, but with the eclipse coming up, with the Jack Space Club, and with all the Rask Montreal events, I am trying to keep that part of it going. But I miss the teaching and the sharing of this love of astronomy, and this is where the Global Star Party comes in so amazingly. Is it gives us a forum to share why we love this hobby, why we choose to spend the extra time sharing it with the world whenever we can. And so today's topic is cosmic fossils, and I'm gonna just talk briefly about this because what I've done is I have actually brought on one of our newest executive at Rask Montreal, Alexi Wiens, and I'm going to introduce him at the end to talk a little bit about a recent adventure of his, but also just so that everybody can get an appreciation of this young man who has done so many cool astronomy and space exploration related activities and travels. And I enjoy getting a chance to chat with him every single time we do. And he's now a student at John Abbott College, so I actually get to see him a little more often, which is fantastic. But I do want to mention, Scott talked about becoming a member of one of the member clubs of the Astronomical League if you want to be a participant in some of the amazing stuff that the league does. I became a member with my family of the University Lowbrows, and Adrian's going to be on later. The University Lowbrows, because they have some of their meetings online, it allows me to still stay connected to that club, even though I'm not in the US and I don't get a chance to visit there very often. So I do highly suggest that you check out some local astronomy clubs. And if you can't find a local one, the University Lowbrows are fantastic. We always start in the Montreal Center with a land and sky acknowledgement to talk about the fact that we are on unceded Indigenous lands. But for us as astronomers, we also share the night sky with Indigenous peoples and individuals and ancient cultures from all over the world. I have one of our Space Oddities friends, Kath Elizabeth, has recently gotten a C-Star S50 and has been taking some incredible images, but she actually, in addition to wonderful nebulae and wonderful clusters, she also takes these beautiful short stacked images of the moon. And so we are at a waning gibbous moon right now. We are just coming out of the January wolf moon, which is what the settlers called it. And given that Dovid gave me the introduction, I have to make a literary reference. And so Gichimanadu, Gizis, the Great Spirit Moon of Ojibwe that we know from the tale of Hiawatha, this is the moon that was with us over the last few weeks. And we always do our public events around the full moon. This time around, we did it on the full moon, but we did it as a live stream with our friends at Guelph Physics. And anybody who was not able to catch the analog experiences, please do visit our YouTube channel, because this was one of my first students. She was a undergrad first term student when I first taught astronomy. So she couldn't take the course that term. But she realized that I was open to doing more, and she came and said, there's this partial solar eclipse coming up next August. And I said, yeah, I know about it. August 2017. It's on our first day of classes. She said, yeah, can we do something for the college? And she led a group of youth to develop our full solar eclipse event. That was just an incredible start to the events that we've had at John Abbott. And now with the April 8th total solar eclipse passing through campus and passing through her campus at Purdue, getting a chance to visit with her now that she's a PhD student at Purdue, training other students to become analog astronauts after she led her own lunar analog experience in Poland. It was just incredible to see the how far some of these students have reached. And she's one of many that I've brought back to talk to students at John Abbott. Now, last Global Star Party, GSP 140, I mentioned some of the work being done by my students working with the James Webb Space Telescope. And when Scott put out Cosmic Fossils, I was a little bit sidetracked, and I was thinking, I might just say something quickly about that, but then I have something else I want to share. And then I realized, listening to Ron's presentation and talking a little bit ahead of the event tonight with David Eicher and others in the gallery, is that really when we're talking about cosmic fossils, it's what we spend all of our time looking at in the night sky.
That's
Whether it's planetary nebulae, whether it's the location where stars were being born when the signals left to get to us, by the time we get those signals, the stars are further along in their evolutionary cycle. And so what we are seeing is always the past. It's always fossil behavior that we are now getting a chance to explore. And I thought back to these beautiful pictures because one of the things that I always regret living in Montreal is the third worst light polluted city in the world per capita, because in the wintertime, snow and ice just reflects the artificial light. So right now, when I go outside, I just see this ambient dome of light, and it's so disheartening not to get to see the stars that we want to spend our time with. That I love it when my students go and get inspired by this and then come back to me with their experiences. So from this fall, I had talked about one of the individuals who made this beautiful Eagle Nebula image, the pillars of creation on the side here from this past fall. And when we had talked about this in class, we had talked about the creation of elements and how exploding stars versus the Big Bang versus, the low mass stars giving off their planetary nebulae, the high mass stars exploding, and then the energy that's left over being able to create the elements even heavier than iron, even though it's no longer a judicious element to fuse to form the fuel that can keep the stars going. The rebound energy allows us to create these these heavier elements. When we talked about all of this in class, one of the things that was difficult was I couldn't take them out that night and show them M1 or show them the Veil Nebula remnants because there's just too much light pollution. So Lucas Loreno Perez, one of my students from the fall, he grew up in Uruguay. And so for the first 2 months of this year, he had decided to go home and spend some time with his family. And when he was home and talking to his uncle about our astronomy course, his uncle said, well, why are we staying here? Let's go for a drive to Atacama. So they drove down to Chile. And he got a chance to experience in the dark skies of the Atacama Desert, the Milky Way and all of this amazing night sky that we talk about, that we look for in the Northern Hemisphere, but we miss out on so much of the splendor and the glamour. And I've had students from New Zealand and Australia send me back images, but there's just something about these images from Chile that are just breathtaking. So I asked Lucas if I can share these on the Global Star Party. And he was touched and he said, by all means. And so I want to share with you a few of Lucas's experiences secondhand to talk a little bit about observing these cosmic fossils with your naked eye. So in the Atacama Desert, we have this beautiful galactic arm rising above the desert. You can see a bit of the mountain ranges there in the distance. These are from a handheld cell phone camera because he did not have camera or equipment with him when he went on this trip. But look at the portion of the galactic arm with the Coalsack Nebulae and Carina, so incredibly visible just with a cell phone picture in the Southern Hemisphere.
Wow. Wow.
He sent me this at 2 a.m. a couple of weeks ago, just as I was getting stressed out about the back to class. And I just stopped and I was like, okay, time to stop stressing. Let's just enjoy this picture. You zoom in, you look at Carina, you get some time to really just enjoy the magnificence of what the arm of our Milky Way shows us for these nebulae where stars are being born and where the remnants of these destroyed, decaying star systems are left behind. And the scale of the galaxy can be visible when you try to capture this same type of an image, but with a different light setting. And you can start to get a feel for depth looking into the dark, dusty lanes of these images. And then every now and then you get a little bit of just wisps of clouds, especially when you're closer to one of the settlements or closer to one of the mountain ranges. And when you look up at the zenith, you can get some incredible, I thought of some of Adrian's pictures the minute I saw this one. This is such an amazing view of the zenith of his experience there in the Atacama Desert. This one took my breath away. At first I was sitting there going, well, I got a little wispy and cloudy. And then I thought that actually enhances this picture because even on a slightly cloudy night, look at how many stars he got to see in that pristine desert horizon. It was just I was in awe.
It's super dark.
And when he had talked about going there, one of the things he was really hoping for was a chance to see some of the amazing telescope arrays that we have down there. And he did get a chance to visit and, well, from a distance, get to see the Very Large Telescope. So he shared a little video with me that I'm going to share here with you. Very short. Gave him this beautiful picture of the Very Large Telescope. And when I was talking to my students in class, one of the things I always joke about is that astronomers, for all the time we spend in our hobby, we really don't have that much imagination when it comes to naming things. So we did name the Very Large Telescope, which is bigger than the Large Telescope, but not as big as the Extremely Large Telescope, which is being built. So he decided to take a picture of the Extremely Large Telescope being built as well in Chile.
Wow.
So I was really happy that with these pictures that he shared with me, I got a chance to at least be there vicariously through the eyes of my students. And that's really been kind of an underlying part of my GSP talks, is that I experience the night sky through the outreach that I do, through the educational courses that I teach, but it's through the eyes of others seeing some of these things for the very first time. So with that, I'm going to say thank you from Rask Montreal.
Thank you.
I have to make use of this awesome video you made us a couple of years ago.
Yeah, thank you. That's
And
great.
now I'd love to bring a new Montrealer on with us, Alexi.
Okay.
Hello, everyone. Thank you guys for having me on. As you know, I'm a student at John Abbott College, and really, when I joined the astronomy group in Montreal, Kareem was the first one there to show me the first constellation I was able to see, which was the Cassiopeia. And from there, my interest just grew and grew. And so it grew to the point where a group of my friends and I have decided to go to Yellowknife just to see the Aurora Borealis in the middle of the worst time when it was the coldest in January. So I'm gonna share.
If you remember from our discussion at the last GSP about the temperatures that we were getting up here, and I mentioned to you the temperatures that were happening up in Northwest Territories and Yukon and Northern Alberta, that's where Alexi was. So that's what he's going to share with us.
Crazy cold.
Yeah,
So
it
Alexi,
was.
we're all yours.
All right. I hope we see everything well. Okay, so without further ado, this was a shot I took from Yellowknife. So this is Yellowknife Northwest Territories, and we'll just begin. So before I start with just talking about the trip, I want to talk about who was on it. We had four amazing friends that I knew for either a while or just recently through school. And these guys helped me through thick and thin during this trip. They're Jeremy, James, William, and Jonathan, all wonderful people. This was the trip we took. We drove from Montreal to Toronto to Calgary, and then Calgary to Yellowknife, and where we landed. But before we got there, my car surpassed 200,000 kilometers, and we all sang happy birthday to my car. And then we started to do our journey on the plane, and we got to see a nice picture of the moon while I was on the plane. And you'll see a little transition where the moon is going from one phase to another. And I went during the best time possible, when the moon was a new moon, where it was the darkest nights. As soon as we got there, we crashed. We were dead tired. It was a long trip. And so the first night, there was no forecast for the aurora on that day, but the next days they were come. We did do a bit of adventuring just outside. Basically, those buildings right there, that's downtown Yellowknife. That's not a very big city, but it was very cold. It was ranging around negative 35 Celsius, which gets pretty cold. And so this is we decided, on the second day we'll go to a nice pub, relax, get to know the people around, and we have this website that we refer to quite often called Aurora Max, and we're just scrolling through the live feed that was happening over Yellowknife, and we saw this. This is not from me. This is from the Aurora Max website. And as soon as we saw that, we dropped everything. We paid our bills of our drinks and chicken wings on that night, and we ran outside, and we were able to capture our first auroras. When I saw this, I was just blown away, speechless. Everyone there was a moment of silence, just kind of just looking above us and just seeing how amazing it flowed through the night sky and everything. But it was still cold. Here's the temperature. I was freezing. It was a dry cold though, but as soon as your moisture from your breath sticks to your skin, you freeze immediately. So we didn't stay too long outside. We ran back to our Airbnb, and then took more pictures, dressed even better. And this was straight out of our Airbnb. We didn't have to go far at all. There's a lot of city lights, unfortunately, but it was still very bright, very active. it was like if you had a string on a table and you kind of just wiggled it around. That's how it kind of moved, but in a more majestic way. And that's a couple of pictures of us. Next day, you know what? Let's have a good day on the lake. We went a little tour and we did a bit of fishing where they kind of had a net already set up for us, and we just pulled the net. We got like 13 fish, and then we ate the fish. It was nice deep fried fish and a nice fish soup. On the next day, on the 10th, we had more pictures. This was the original picture I showed you guys. This was basically behind our Airbnb. There was a little hill that was farther away from downtown, and we got some really nice pictures. It got really cold. We started seeing ice crystals and everything. And condensation was forming from the buildings and everything. And it was on that day, it was -40, and -40 degrees Celsius is the same thing in Fahrenheit.
Wow.
It's that
Crazy.
cold where Fahrenheit and Celsius mean the same thing
Oh,
at
man.
-40. This was supposed to be our last supper, as you probably remember. In that first couple weeks of January, it was -40 in the prairies and everything. So the flights were canceled the next day. But we had a great meal at a another local pub. We watched a Habs game. Of course, they lost. No big surprise there. So yeah, the nightmare begun. The classic canceled or delayed flights started to pop up on the board, and so we decided, you know what, we'll go back to the Airbnb. The lady was very nice. Let us stay an extra night there free of charge. And this is basically what it looked like outside. Everything froze over. It was absolutely frigid out there, just to say the least. We took that extra day, do a bit of exploring of the city and the place around. There's my friend Jonathan. We found a random chair sitting in the middle of the lake. And we decided to lounge on it a bit. Next day, we went to the airport to get our next flight on. It was -44 Fahrenheit. That is in Fahrenheit, so it's very cold, very cold. That's the airport. Well, from the airport, and there's one of the planes that was being boarded on, and of course, delayed. Or was it? No, it was canceled. It was canceled for the second day in a row now. And so we decided, we didn't have a place to stay, so we took over the airport. We sat around, we took a corner of the airport, basically. It was not a very big airport, and we just slept there, and we had a bit of fun there. We even played some hide and seek at the airport. That's how bored we were. The 13th, just as cold, just a bit warmer. 1 degree warmer is the lowest temperature, but it was pretty cold. And our flight was once again canceled. It was going to be canceled until the 15th. So we were going to stay there for 5 extra days. We didn't have a place to stay, but fortunately we were able to get tickets. We were on WestJet, and they moved us to Air Canada, and we were very excited. So as you see, there's the moon. It's now on a different phase, and that's from the hotel that we were fortunately given on the last day, because there was not enough crew for that flight. And so we started our departure, but our adventure did not end there with the auroras. We got to see auroras on the plane, which was crazy. Like I didn't think I was able to do this. This was about 5 o'clock in the morning.
That's incredible.
Flight.
Yeah.
Yeah. This was from Yellowknife to Vancouver, British Columbia. And here, I've wanted to go one by one on them. And here, as this is a close up of it, I was able to actually take a look at a constellation. And I just, my art is not the greatest, but I hope this will suffice. This is basically Ophiuchus. I hope I didn't.
That's fine.
Ophiuchus, sorry. I don't pronounce it correctly. I do apologize. And so that's one of them. And on the west side of the airplane, I was able to take two. They captured two of them in the Aurora. The first one being which one is it? Oh yes, it was the Auriga constellation, which is right next to the Gemini. That was visible also. Again, I was not expecting this. Basically, what I had to do is, because we had those screens on the plane, so extra light that we didn't need, I took my winter jacket, covered myself, took my cell phone. This is through cell phone footage also, and put it on night mode. I just stood there, took a picture, and was able to take great pictures in the sky. Never thought I was able to do it.
That's really cool.
We ended it off with going to Vancouver. We had a 4-hour layover roughly, and so we left the airport, ventured off, and that was the end flight. That is all. Thank you guys
Thank you.
for taking your time with me, and
That was
it was an honor.
Alexei.
Thank you.
I'm curious about something. I've never
Yes.
visited up that far north in Canada.
Yeah.
I did fly over Greenland one time and was able to see, you know, amazing auroral displays from the plane. But is it Yellowknife must be like a prime destination to go see Aurora? Is that correct?
Yes, there was actually lots of tours, but we decided not to go with the tours. We felt more like independent, and we wanted to
Yeah.
experience it for ourselves. But yes, it's actually a quite Yukon and Yellowknife are huge tourist destinations for the Aurora.
Mm-hmm.
Yeah.
Mm-hmm.
And you have, so David has left, but a few years back, he had gone as one of the guest speakers for the Aurora 360, which was an airplane that went through the auroral curtain as part of an experience in late February.
Oh,
That,
wow.
unfortunately, during COVID, that just ended up having to close down. But that wasn't that was out of the Yukon, but they flew basically over the border to Northwest Territories and then back into Yukon.
Yeah.
Wonderful. Wow, that's great.
And I think
Well,
we're
you
going
guys
to be
were
hearing.
brave to brave that extreme cold. You know, I was
Yeah.
reading about what can happen to the human body at minus 40, and got down to minus 44. It's dangerous, actually. And so, any special tips for staying warm in that kind of weather?
Keep your feet dry.
Ah,
Keep
okay.
your feet dry. Keep everything dry, because if not, you're gonna freeze. You're gonna freeze, and keep some
It's
hot
gonna
pockets
freeze
with you.
Oh man, yeah.
Just
Well,
thinking about that has Scott kind of cold and rubbing his arms there.
Yeah, I'm like, it's
I
like a
wanted to mention,
phantom cold feeling, phantom chills. So
I think we're going to be hearing more from Alexei because in addition to his space shuttle journeys, he's been working
yeah.
a little bit on some of the Messiers and starting his own observation list. So I think
Oh,
we'll be
that's
able to
great.
follow his journey over the next little bit.
That's great. Well,
I hope to share it with you.
Yeah, you're welcome to be on Global Star Party anytime you're ready. So you just let us know.
Thank you.
That's great. Okay, folks. So we are going to move to our next speaker, and that would be Marcelo Souza in Brazil. So let me switch our camera views here. Take care, Alexei. Thanks
Thank you.
so much. You did a great job, by the way.
Thank you.
Yep. Marcello, how are you?
Hi, I'm fine. Can you hear me?
We hear you better now. Yes.
Okay, thank you. I'm sorry because here in a hotel now. We
In a
are
hotel. Oh,
in a
okay.
hotel, yes, in a city of Santa Maria Madalena, where is
Uh-huh.
located the first dark sky park of Latin America here.
Oh,
We
wow.
we are since Friday visiting different cities here in our state, Rio de Janeiro, where we have a dark sky. And we have a member of the staff of Dark Sky here with us. That's Megan Ives. That's a journalist. She's here with us. and we have the opportunity to visit the first dark sky of Latin America again. And also we are visiting other places that in the near future can be the next dark sky park here in Brazil. And the
Wow.
hotel where I am here is also, they also want to be a dark sky lodging because it's very dark here. Here is part of a forest here, a private forest.
Yes.
And today we were, before the beginning here of my participation program, we were outside looking to the sky here, and we saw the Milky Way. It's so dark here that we can see the Milky Way, and we were looking for the Southern Cross begin to rise. It's not in the beginning of the night, but a little later, it's already appearing the Southern Cross. There's a fantastic view here. And the measurement that we make with the SQM to measure the quality of the dark sky, here is more than 21. That looks like a place that is very dark at night. If all the lights, they turned off all the lights, and it is a fantastic place here. And I think that soon we will have new dark sky places here in Brazil. It was a fantastic experience this 5 days that we visited 5 different places. Yeah, and I think we have good news today, Scott. Today it was launched the new edition of the Skies Up magazine. It is a wonderful magazine. And Scott, I would like to ask you if you can help me to sharing the new edition of the magazine because
Yes.
I can't manage this here.
I am going to post the link where it can be read for Skies Up magazine. By the way, Skies Up is a absolutely free magazine from the Explore Alliance, and Marcello Souza is the editor. And so we just published the latest edition this afternoon. So it's fresh off the presses, and if you click on the link, you can read it or download it.
And this
Or both.
edition, we have something fantastic that we have articles from people from 3 different continents. We have from Americas, from Europe, from from America, from Asia, from Africa. You have articles from Pierre Paquette from Canada. You have
Amazing.
articles from Dr. Dale Levy, from Scott Roberts from United States,
I love it. This is great. It's great.
from
Global
from
Star
South
Party, Global Astronomy magazine. Yes.
from South America. We have articles from Brazil. I wrote one. From Argentina, from Uruguay, and the 2 articles from Argentina and Uruguay is about experience with dark skies. They are directors of the dark. One is Alejandro Sommer, that is director of dark sky in Argentina, and the other is Fernando, that is director of the dark sky in Uruguay. They show their experience there. You have an article from Egypt, that Dr. Bashir, that has experience with solar observation. I have also, Dr. Dave Levy is here. Hi, I saw him. Nice to meet you. Dr. Bashir, he works in Qatar now. He's from Egypt. Now he's in Qatar. And that is in Asia. And he works there with solar observation, popularization of the solar observation. They do research, studying the sun. We have also an article from Pakistan, from Yuma, that developed a fantastic project there, they offer outreach activities, teaching astronomy there, and an article from Nepal that is written by Suresh Patarai, that also he is very active there, developed fantastic project there, and he talk about their experiences to develop astronomy in Nepal. And also you have information about the next eclipse in United States. Then I think that I didn't forget anyone. Sorry. Could you show the magazine, Scott? Because I can't share here the image.
Oh, let me do it. Let me do it. Okay, hold on.
Pierre Paquette, that is written a series about the history of astronomy. Have a
Here we
special
go.
article from Dr. De Levy, a special article from Scott Roberts, and it's a free magazine. It's fantastic, Scott, this magazine. Thank you very much. And
Yeah, thank you. Great article by
Christian,
David Levy.
yes, a fantastic article from Dr.
Yeah.
De Levy.
This is a great companion. This magazine's a great companion for the Global Star Party because of its global nature. You can see, some pretty interesting articles from around the world. There's also very interesting articles or contributions of star charts from Will Tyrion. So probably the best celestial cartographer of our time, makes the star maps for Skies Up magazine. This is great to see artifacts in the Galileo Museum. We support in the magazine people that support the astronomical community at large, and Astro World TV is also one of these great groups that puts together regular programs with Dan Higgins has been on Global Star Party plenty of times to share with us what's going on there.
I remember you have an article from Europe. I forgot the article that from Yanni Roberstad, that is the manager of the Global Science Opera. That this year, last year, 2020, and this year, the theme is about astronomy, the James Webb Telescope. And the Global Science Opera is a fantastic project. The director, the coordinator, already participated in one global star party that is already being ring.
That would be great.
And a fantastic experience of Global Science Opera. Here, this article about the experience of the Global Science Opera, the astronomy in Global Science Opera. That they is a mix. They make the interaction between science and the arts through the music. That's a great experience. The article. Then this is from David Prosper. That is from the Night Sky Network.
Mm-hmm.
Is a way, this magazine is
It's
a way
wonderful to see all this, activities in educational outreach and astronomy, working with young people. And, young people are naturally interested in the stars and, learning about the universe that they're part of.
And the woman is developing a project in Pakistan. She's a woman that developed projects in Pakistan. And
from Pakistan.
Yeah.
Wonderful.
Fantastic.
Wonderful. Getting to know our star.
Yeah, this is an article from an Egyptian that
from
now
Egypt.
lives.
Okay.
No, he lives now in Qatar. He works in a university in Qatar. He has a PhD in solar observations, and he do research about the sun there. And he developed many outreach activities there in Qatar. But he is from Egypt. Yeah, images of the solar eclipse that there look.
The Great North American Total Solar Eclipse. I love the poster. It's awesome. Yeah.
And in April, I think that everybody in the United States will be to see the eclipse.
Are you coming to Mexico or to
No,
the United States for this eclipse?
not this time, not this time.
Oh,
Unfortunately,
oh, too bad.
we are planning for in October to see the eclipse in Argentina.
Yeah.
That will be closer for us.
So some great planning information for the eclipse.
It'll
Here
be
we are,
fantastic.
state by state.
But
This
it's the
is good.
third eclipse in the last year in the United States, no? Because last year we have an eclipse, and a few years ago again
Yeah,
you had
2017 we had a total eclipse, and then last year we had the annular, and of course this year the total.
in 7 years 3 eclipses. Is something.
Yeah. This eclipse in 2024, if you don't already know this, will probably be the greatest science event in human history. There will be many, many millions of people that will witness this. This eclipse is going over some of the most populous areas of the United States. And that part of the United States also has an incredible network of highway systems so that you can get to the center line pretty easily. But you need to make your plans now if you haven't already made them. And if you have not already bought eclipse glasses, I can tell you that the United States is running out of solar filter material, okay, by everyone. And so this is, if you're thinking that, well, I'll wait, I'll buy my eclipse glasses 4 to 6 weeks before the eclipse, there's a high chance you won't be able to find one, except maybe you pay an extremely high price for it. So,
Wow. And Scott, in the last edition of
yeah.
Sky Up, you showed a place where this place they saw the eclipse in 2023, and you see again in 2024. Where is this place? Do you remember?
In 2003, you said?
Is a place where you can see both eclipses.
Oh yeah,
2023
2023. Yeah.
and
So this place,
2024.
this is an event that Explore Scientific and the Explore Alliance is running, and this is called the Crossroads of the Eclipses Star Party. Of course, it's going to happen during dark of the moon, so people will probably start arriving like April 5th, I would believe, and it is at a ranch, a private ranch on the center line in southern Texas. And so David Levy will be there giving talks along with a bunch of other people that are eagerly awaiting to see totality. And we can't wait for this day to arrive. It is coming fast, and being in the business of selling eclipse glasses, it's kind of crazy because people are ordering heavily right now, and well, it's the kind of business that anyone that's in this industry would like to have, but it can get a little overwhelming because of the surge that happens just before an eclipse is occurring. Love this article. Half the world happens at night. That's right.
This was written by Alejandro from Argentina. His
In
experience
Argentina. Okay.
yes,
Oh,
experience
that's
that
great.
he has with indigenous there.
Yeah. Some great astronomers all throughout the Americas, from south to central to north. So it's awesome that we can highlight these things in this magazine.
He's developed a fantastic project.
Yes.
And also he's the director of Dark Sky in Argentina.
Ah. Some great images of planetary nebula from Doug Struble. Doug has his backyard observatory, and he is like something like 6 or 7 miles away from downtown Detroit, extremely light polluted. He has lights that are turned on from his neighbors. He's got the city lights to contend with, but he does all this in narrowband imaging. And, unfortunately, you can't really appreciate the depth of how great these images are because we're broadcasting, and so there's some data loss. But if you go online and type in Doug Struble planetary nebula, you are going to see some extraordinary shots.
Great, fantastic.
Yeah, some really wonderful contributions in astrophotography. And then, the final shot there's the Tulip Nebula. This is the Wiltirian star maps that I was talking to you about. And it's for northern and southern hemisphere and winter, spring, and summer skies. So, helpful reference there. Very accurate. And then this beautiful parting shot. I did not see this. This is wonderful. But that's from NASA and ESA and others at Space Science Institute or Space Telescope Institute providing these images. So looks like a lot of J-West shots. So wonderful. Wonderful job. Thank you very much, Marcello.
Thank you very much for the opportunity to contribute for this fantastic magazine. I'd like also to thank Tricia for the fantastic work with the layout.
Yes,
the magazine
Tricia here does a good job in putting it all together.
It's very beautiful magazine. Very beautiful.
Yes.
Thank you very much. It's a great pleasure to be here.
Thank you very much, Marcello, and you have a good night and enjoy you're on vacation, is that right?
Yes.
Yeah, okay.
Vacation, but working because I'm with my family is here also.
That's wonderful.
We can trip for 5 days, and tomorrow morning, very early, we will go to Rio de Janeiro because she will take the airplane and we will follow her. It's a great pleasure to be here. Thank you for the invitation. Bye.
Yeah. Well, regards to your family. Thank you very much, Marcello. Take care.
Bye.
Yeah. Okay. Our next speaker is Adrian Bradley. Adrian always wows us with his incredible night sky shots. Much of it taken in the Michigan area, Upper Peninsula area. But he does travel, and he never hesitates to take some wonderful shots, even when there's a little bit of adversity like light pollution or clouds. He makes incredible art with it. So, Adrian, thank you for coming on to Global Star Party.
Thank you, Scott. As always, I decided to try a new webcam, and I'm thinking I'm going to have to go back to the old camcorder and make that work. This one fires up easily, but obviously it makes me look like I'm half of a ghost here. But it sits nicely on top of my monitor.
Green screen effect.
Yeah, I've got probably from the green screen background, but
yeah.
Well, so today we were talking about, I think we were talking about origins, and there were so many good presentations. The atoms in our body and things of that sort. And I decided I would share a revamping of a project that I'm doing, which shows rise and fall of Milky Way in the northern hemisphere. And I'm going to end it with a quote from the dear David Levy. Let me get right into this and just share the screen here,
Mm-hmm.
and you can see the project here, and you can see there's a poem here by our esteemed
Yes.
and beloved Dr.
Yep.
David Levy. I may change the font so that's more readable, but your eyes on the sky adaptation to the eyes on the sparrow poem. And just so that you know, David, every time I look at the sky, no matter where I am in all of these pictures that I plan to include, um, it always grounds me, takes away the anxiety of being someplace where maybe it's really dark. Um, places like this, if it shows up, where I'm surrounded by a lot of
Oh,
trees.
wow. Yeah, it's
Um,
beautiful.
I look up at the sky and immediately feel a sense of warmth and comfort. So I'm no longer
Yeah.
worried about things that are coming at me. And
Yeah, the troubles of the world. That's right.
yes, and you might notice this. I've changed the music for this. I had a beautiful Catholic piece done by Fernando Ortega in the original when I originally put the little slideshow together. The music
Mm-hmm.
was and I'm drawing a blank on it. It's one of my favorites. I heard the voice of Jesus was the a piano
Hmm.
solo, but I remember David, you always said that the images were like Mozart, and I said, well, we're going to pair Mozart with this. So obviously I won't be playing it, but I am going to try and and have this record, and and I'll show you exactly what the all of these images to the Ein Klein Nacht music. I think it's the opening act song. So it's one that we've heard. Um, and so the idea is going to be it's going to show, and the main character here, Orion, we start with an image I took where Orion, the rosette, is up here, and I have this, which I may just move right now. Let's see if we can. Um, oh, we tried, but we failed. We should be moving we shouldn't be moving the sky here. The sky stays constant. So we picked the wrong thing to move, but we will put that back. Um, and my machine is not the fastest of machines, so I will have to fix that. So the idea is Orion, who starts up here, now goes here, and gradually Orion will set. And then as Orion sets, we'll jump ahead. We'll jump ahead to this picture with Aurora. Something else is rising. Out of the happens to be rising out of the Aurora, but if you know your Milky Way, you recognize this as the North American Nebula. So you instantly know this is Deneb, so you know that this is Cygnus, and that Cassiopeia is somewhere behind it. You know that this is a double cluster here buried in the Aurora. So what that means that to the northern hemisphere, the Sagittarius dark cloud is here. To the northern hemisphere, there's something rising, and the center of the galaxy is making its way up. And when I get to this image, you see the entire bit of the galaxy, the center of the galaxy as we can see it in the northern hemisphere. And you see some other renderings from other locations, including this location. I'll briefly mention this cabin once belonged to one of our priests, Monsignor Daniel Trapp. And on Friday, we learned that he had passed. So um, sadly, I had some opportunities to take a picture of him and this cabin at night and pass them by. But
Great shot. It really is.
that's So the theme here of the Milky Way rising, and there is one image that I will be adding. It's a picture of me sitting there looking or watching the sky, and that will make its way into this image, and will likely be the last picture. So the idea is, you see the galactic center begin to rise. We'll be jumping ahead a little bit to you're going to see this standing on its end. Here I am looking at it. This could, if weren't for the position of the Milky Way, this could easily have the poem in it. But as time goes, and let's see if this is so there are photos here. I've added some newer ones that I've taken, such as this one, the storm on the side of Milky Way rising, and one of my favorites. And I left this one in with a dark cloud, so you can see, Milky Way is rolling over, and all of these different locations, a lot of Lower Peninsula, Michigan, some Upper Peninsula, and you recognize the few of these. Like if we go back to this one, you'll recognize that this is a field. Behind us is the observing field at in Kenton, Oklahoma, where Okie-Tex is. The Okie-Tex Star Party happens.
Super dark area.
Yep. This is another reasonably dark area, and you can see the Milky Way is rolling over gradually, and you can even tell by the color of the trees here that we're looking at fall, and it continues rolling. And this scene, I still feel like I didn't do it quite enough justice. The first time I saw this with my own eyes, I was blown away with this. There was another gentleman who was with us and looked over and said, "What's that?" And we said, "It's the Cygnus region of the Milky Way." We generally don't see it like that in Michigan. In Michigan, we see it like this.
I see.
It's the difference in what there's a North American. This was a little wider lens, but
yeah, maybe the humidity or that moisture in the atmosphere makes
and darkness. It's not. It's the Bortle zone here is just not as dark. It was cloudy, but over that at the Okie-Tex Star Party, the Bortle level, the darkness is a lot. There's a lot more. So I've added this. This is my most recent photo. It ends up here because of the angle of Cygnus in this part of the Milky Way.
Yeah.
So, and then this is a final image of it.
That.
Yep. Using
the
the
fountain of galactic material. It's awesome.
Yeah. And you can see all of it, even over this frozen wasteland of a lake. This is where Lake Huron and the Saginaw Bay in the thumb of Michigan, if you look it up, that's looking out over this area. And so what happens, we return to Orion, and we get near the end of our video watching Orion return to the night sky. And we see gradual this. For those who recall Skies Up magazine, you'll recall that image. That's what I left in. Yep. And then we continue on. Zodiacal light is a part of that image. The Magellanic clouds would be somewhere just below my screen, below the horizon. Would love to have Southern Hemisphere images in here, but this is a fairly recent image. As you can tell, I'm focusing on the detail in the ground to the point where this is becoming more and more of what you would see with, of course, enhancements of the hydrogen alpha that's in the sky. All these other elements are showing colors based on what those elements are. And this really bright area is Port Huron. It is very bright. And then over here you have Canada. And so then here we are, we're back to Orion, and this particular is where I'm saying in a year's time, the sky returns to where it started. And then at the end, of course, is David and his poem, which I don't know if I can play any of this without this music playing. It might, because I didn't allow for video, but this appears at the end. And what will happen, there's more of this song, and what will likely happen is I'm going to shrink this and then look for a picture that I took of me seated, and I believe I can show you that picture. Picture that I want to end with in this, all these pictures. There's this part of the Milky Way that may end up making it into the making it somehow, but the idea behind the photos, and this one should go in there too, from Denver. But the idea behind the photos is that I want to show this part of the Milky Way from the galactic center rolling across the sky as the as the months roll in. And there's a few more storm images that could get swapped in this image, which I would love to include, which I probably still will. Is this is AT&T. You got cell service over here.
Yeah.
And then you've got this, I think, is a planet. I want to say that this was either Saturn or it may have been Jupiter, but it's something we can always look up. Of course, sharpness, you see the noise reduction, sharpness of a Milky Way image. I always go back to Barnard's E right here, and let's see. And Tarazed is the star here. Now things seem to be a little blown out because it's not its normal yellowish color. Altair is here, and Tarazed, and Barnard's E. If it looks kind of like an E or like a disjointed E here, you've got a reasonably sharp image. You've got this LDN object, and that looks kind of like Plankton, the character from SpongeBob. If you can see that,
that's right.
then you've got a pretty sharp image. This LDN is in Hercules. And someone mentioned the butterfly. Well, it's not going to show up because this has moved too far along. But M23 shows up really nicely when you have a reasonably sharp image. So
it's a very nice image.
Yep.
Folks, if you're looking at these images and you really like Adrian's work, he does make it available for purchase.
Yes.
And I'm sure he can be talked into signing them as well.
You got it. And I'm going to, this year, I'm going to work on making more of these available for purchase. Of course, I use all of these for outreach where I can. But, with enough interest in hanging these on your wall, I am more, and especially this one. I think I have this one for sale here. But, we're talking about the progression of the Milky Way. So these images are going to make it in. This one in particular will show up in that project when I find the original with this lighthouse. That one.
That's great. That's really
and
majestic.
that, yep. And where it's going to show up is in between the once the Milky Way rises to a certain point. It'll likely be this one. and we may even try and throw this panorama in there. But again, the idea is you've got the plane of the galaxy moving across the sky, and over the year it flips, it rotates from this summer version to the winter version. And again, somewhere in here I was sitting and just observing the winter version. Here's this image, which may make it as well. So I should take notes on some of the images I'm seeing. This image is these two images are a part of the slideshow, and as is this one. These are two versions
really
of it.
stuff.
This one is, yeah,
You're
very
really starting
colorful.
to master this stuff at this point, Adrian. That's great.
Yeah, and I know that there are many who do this sort of imaging, and I've run into a few in Michigan that do great images. There's many ways to go about it. This image in particular is, it looks like things are on fire over here. So not everything is perfect, but, enjoying the natural world is, even with, this is a partially eclipsed moon, and we're in a civil dawn, and this moon is just now getting beyond its, and I don't know if it'll sharpen up. Okay, it did. So you can see a little detail here. This moon is slowly coming out from behind the Earth's shadow as a part of a lunar eclipse. These are some earlier pictures of it. And this might make the slideshow. There's other images I've taken that I want to add to the slideshow to highlight that Milky Way. And this is the image that will likely end the slideshow with me sitting there. And this, it's a bittersweet moment, because here I am sitting at that same, looking out over the lake at Orion, at the same cabin that my priest, who is now passed on, that's his cabin, and he gave me free reign to take images from it. And this was one of the images that I took. I decided to do a self-portrait of me looking at the sky, and with David's words here, that's the plan, is to end that slideshow. Even though Orion is in this position rising, this may make a good beginning or end. So I'll decide where it goes. And and then we'll go from there. But definitely captures the spirit of me just observing the night sky, the spirit that I want to convey in this slideshow. So there's more to go. And as Scott once mentioned, sometimes your sky just has clouds in it, and never hesitate to take photos whenever you get a chance, because you never know.
Look at that.
Yeah, you never know what interesting. This giant thunderhead became a really good opportunity for a reflection, and you've got stars up here, but if you're under this part of the clouds out in the distant lake, you're probably not having a good time. And this thing slowly moved east. So
it's all temporary.
Yep, it's all temporary. And so with that, I will stop. And
thanks, Adrian.
Yep. And
thank you.
Yep, we're turning it over to someone
Robert
who
Reeves.
does a really good job, Robert Reeves, who does a really good job with images like this and even better ones. So it is an honor to hand it over to you.
Well, thank you. It's a tough act to follow with all of that. That's a phenomenal astronomical landscape photography. And
thank you.
The term for it escapes me at the moment. There is a term for that.
I think it's nightscapes or landscape astrophotography.
Nightscape photography.
Nightscapes.
Yes.
I like calling it like nightscapes myself.
Yeah, that's what I think that's what Babak Trafishi, the kind of the instigator of that style of photography, called it. And yeah, it's really phenomenal what people are doing nowadays, and it's just growing like topsy. The skill level is just ramping up fiercely, and
Yeah.
it's really hard to pick who is best nowadays.
Yes.
Yeah, it is, which is why I decided I would just go after what I like to see in images. Sometimes I'll take images that reflect exactly how I'm seeing the sky, even if that means the Milky Way is not prominent. Other times I'll make the Milky Way prominent because I just want to see it blazing. It depends on the purpose of the image. But the one thing I do love to do, competing in this space, is near impossible because
Oh yeah.
it goes from we've all seen it. There are some fantastic images, but I think they may get to the point where if they get to the point where David does not recognize that sky, then it's not a good image. If there's just too much there, that's just, and there's some images that are processed that when noise reduced, the nebula are removed that are along the plane of the galaxy. And I just don't want to do that.
Or some of the small stars disappear as well.
Yeah,
But,
those small stars.
A combination of good artistic eye and proper image processing, it just blows me away what some people come up with nowadays.
Yes.
Agreed. Well, thank you for coming on, Adrian, and you too, Mr. Reeves. We are excited to get our dose of lunar knowledge from the real master here. So thank you so much for coming on to our show.
I'm not sure what happened. Everything just vanished. And can you hear me?
Yes.
Yes, we can.
All I see is a big white screen that says Zoom. You and Adrian just vanished. I'm not sure what's happening.
Try Alt-Tab.
I have it just on you right now, so don't worry about that.
Perfect.
Yeah, but I can't find the share screen anymore.
Uh-oh. Try hitting Alt-Tab. Let's see if
Alt-Tab.
it just went to the background.
Yeah.
Alt-Tab.
Yeah, hold down on Alt and just hit Tab.
Nope, nothing is happening.
Nothing at all.
Oh, that's weird, because I was sitting there watching you and Adrian, and all of a sudden, pop, Zoom pops up. Just this. What the?
Or you can minimize Zoom. You don't have to see it at first, and then bring it back, and maybe you'll see the share screen.
Yeah.
It sounds like it's gone full screen for you.
No, that is not working. I still see this Zoom thing. Oh, this is.
I know you've had those issues before, but it's always worth it for when you muddle through the issues.
Okay, I'm staring at myself now. This is a good sign. I'm going to hit.
Okay, there you go.
Share screen and go to this.
There you go.
And okay.
There you are. Perfect.
We're saved.
First time.
Postcards from the Moon is back. Yep.
Yes.
Alrighty. Let's see if it actually advances. No, it doesn't advance. There's a way we did this before. Let me. We've had this issue before. There it is. Alrighty. Alrighty. The other thing tonight. Can you see the full moon now? Did it advance?
Yes.
Oh, good. Okay. Well, the theme tonight is, cosmic fossils. I like to think of the moon as a gigantic geologic fossil. It's been up there for about 4.6 billion years, just a little bit less than the age of the Earth itself. Backing up the Earth, the current Earth, the Earth we are on now, and the moon are about the same age because they were created by the same catastrophic collision. The original Earth, about 100 million years younger than the moon. But as we look up at the moon in the night sky, particularly a rising full moon, we see all these dark maria that create the face of the man in the moon. And these maria lie within giant basins that were blasted out of the moon between about 3.8, 3.9 billion years ago. So everything that we see on the moon that happened before these giant basin creation events, we call it the pre-Nectarian era. That's from when the moon was created up to the time of the Nectarian epoch, which only lasted about 100 million years. But that's when the giant basins on the moon were blasted out by a fierce rain of asteroid impacts. And then later, these basins, the lowest ones below mean lunar elevations, filled up with dark basalt to create the lunar seas we see today, the man and the moon. So we can look up at the full moon and see this cosmic fossil when this division in time happened. We can see it with our naked eye. These round maria that form the face of the man and the moon are a line in the sand where everything after that was a specific geologic age. Everything before it was a different geologic age. Well, tonight we're going to look at craters on the moon that predated the Nectarian epoch, that are older than these giant basins that now cradle the Mare. So well, I'm not going to do a specific tour of them in any for any particular reason. Just kind of drifting from the east side of the moon over to the west side and looking at these features that are more than 4 billion years old. So the first one, let's see what happens if the first one is Vindelinus, a crater that is nestled in between Langrenus up on top and Petavius on the bottom. Those are very familiar craters to moon watchers, Petavius and Langrenus. Very classic complex craters with central peaks, but nestled in between them is this real old guy. Vindelinus is pre-Nectarian. It was there before the giant basins were formed. And in fact, it was ruined and completely filled in with debris. Its central peak covered over, its terraced walls swamped with debris by the impacts that created the Great Basins. The storm of debris thrown out by these impacts ruined all of these pre-Nectarian craters. So they're overlooked a lot of times. People look right at Vindelinus and don't recognize it. Whoops. Yeah, that's not working. I'm trying to go to my next slide. Let's do it this way. Alrighty. Now, like I said, people look right at Vindelinus and barely recognize it. It doesn't look like your standard crater. Filled with debris, no central peak, no terraced walls that give it that unique look. But this feature has been around almost as long as the moon itself. So this is a true cosmic fossil. And having to do this the old-fashioned way to advance them. Whoop. It's funny how it's advancing sometimes and not others, and advancing when I don't want it to. All righty. Another old guy, Janssen, down in the southeast part of the quadrant of the moon. Janssen is huge, 191 kilometers in diameter, and pre-Nectarian, over 4 billion years old, and it's kind of like the it's the giant elephant in the room, but we're blind to it. We only see Janssen at sunrise or sunset. Janssen is almost 200 kilometers in diameter, yet it's only about 2 kilometers deep. We rate giant craters by the size of them and their general shape by something called the D over D ratio, the depth over the diameter ratio. And with most large craters, that D over D ratio is somewhere around 1 over 25, meaning a 100 kilometer diameter crater will be about 4-5 kilometers deep. But Janssen has a D over D ratio of 100, 1 over 100. It's only about 2 kilometers deep, 200 kilometers wide, and unless there's very low sun elevation creating these deep shadows within it, it will disappear. So let's go back out, advance to the next one. make it big again. And here is an example of that where the sun is a little bit higher. And unless I hadn't told you that Janssen was right square in the middle of the field of view, you might overlook it. You might have your eye riveted on Fabricius, the more well-formed crater within Janssen, or you might see Riemann Janssen, the curved rills within it. But Janssen itself vanishes under very high sun, as we will see in the next picture. Trust me, Janssen is there, right in the middle of the field of view, but you can't see it anymore. Yet it's a 200-kilometer wide crater. So, moving on to another one. Up in the northern polar regions, up above Mare Frigoris, up above the man in the moon, Mare Frigoris being the man in the moon's eyebrows. Further north, we're in the polar territory, and almost all of these craters up here are ancient and filled in with debris from the explosion that created the massive basins. And in the foreground, if you can see my cursor, notice a very square looking crater. This particular one is W Bond. And again, very shallow, debris filled, central peak missing. The same with the complex of 4 craters. Dang it, I'm hitting the wrong button again. Back up. There we are. This complex of 4 overlapping craters here, Meton, also pre-Nectarian, and the interior of it completely filled in with debris that was heaved out of the basin impacts. So all of these craters up here, almost as old as the moon itself. And if they're heavily debris filled, you can't see their central peak. That's a very good indicator that they are pre-Nectarian and very ancient. Moving on a little bit further. We come to J. Herschel. You would think that William Herschel would have the bigger of the 2 craters named in the family. Well, actually, Carolyn Herschel has a crater named after her as well. But no, John Herschel, the son, has the biggest crater, 156 kilometers in diameter. It lies right on the shore of Mare Frigoris, just a little bit north of Plato crater. And again, you see completely debris filled. You can't see the terrace walls. The central peak is gone. Another crater that is over 4 billion years old. We're looking back almost to the birth of the solar system. And toward the middle of the moon, down toward the equatorial regions, we've got Stoffler. Oh, well, back up. Stoffler on one side, Maurolycus on the other. Maurolycus is a little bit younger, but Stoffler is the old guy, pre-Nectarian as well, and originally a fairly good-sized crater, 126 kilometers in diameter. But in the melee that followed its creation during the Nectarian epoch, when all of these asteroids were bashing into the moon, poor Stoffler got whacked by 1, 2, 3 craters that overlap on top of themselves and obliterated its eastern rim. And of course, the interior now completely filled in with debris, the central peak missing. And even Maurolycus over here, a little younger. It is a not pre-Nectarian, but you can see that it got beat up in its old age as well. In fact, Maurolycus, an older crater protruding out from underneath Maurolycus. So this is a pretty interesting place to be 4 billion years ago. It was like a battle zone. I mean, just blast after blast, creating giant holes in the ground and overlaying each other. And pushing on to the next one, a fellow named Orontius. Same thing. Here's Orontius right here, following my my cursor, 123 kilometers in diameter, and the same thing. Pre-Nectarian, settled down for a nice long winter's nap, and then whap, 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 all these other craters, Leana's rim. So kind of a cosmic shooting gallery back then, where nonstop action, all these craters piling up on top of each other. And a crater that was just named within my lifetime, Deslandres. You're probably not going to recognize it if you don't know exactly where it is. And Deslandres was not recognized as a crater until the 1940s, when Antoniadi named it after Henry Deslandres, French astronomer. And you can see the outline of it here, barely. Depending upon how you measure crater diameters, the next three, this and the next two craters we see, all at one time or another, have been claimed to be the largest craters on the moon. This Landers, you can look it up and it'll say that it's 235 kilometers in diameter. Well, that means it should be the largest crater on the moon, but then you could look up Clavius and Chicard, and it'll give you figures that are similar, saying that that one might be the largest. So, like I said, it depends upon how you measure it. They're not perfectly round, so depending upon which way you cross the oblong rim, we've got three craters here that are vying for, I'm the biggest. But like I said, Deslandres, named in the 1940s, but for centuries, it was simply called Hell Plain, and not because it's a place that's hot as heck. This crater here is Hell Crater, named after Father Maximilian Hell, a Jesuit astronomer. But the crater was not recognized as being a crater until the 20th century, and then finally got its own name, Deslandres. And it's fairly easy to spot. Once you find the landmark Tycho crater, which we see here, just a little bit north, there it is, boom. Just tucked off on the eastern shore of Mare Nubium, the Sea of Clouds. And moving on, Clavius. Now, any way you look at it, Clavius is big, 225 kilometers, according to some measurement, a little bit different with others. But in all of the astronomy texts that I had when I was a kid, and I'm talking about before the biggest crater on the moon. Of course, now, like I'm saying, there's a little debate over exactly who's who, but Clavius has got a personality simply because of the craters on its rim, Rutherford and I forgot the other one. These two very artistically placed craters on its rim, and the arc of progressively smaller craters sweeping across its interior. So it's a crater that has a personality because of past impacts. But Clavius, pre-Nectarian, been around about 4 billion years, and as you can see, it's been around the block a time or two with subsequent impacts. And moving on to another view. Here we see Clavius on the bottom, and we see Tycho on top. There's a factor of 40 difference in ages between Tycho crater and Clavius and Longomontanus and Maginus, these other similar aged craters with Clavius. Tycho about 108 million years old, and Clavius and its neighbors 4 billion or more years old. So, like I said, an age difference of about 40. It's like Tycho is the toddler and Clavius is the grandpa bouncing it on his knee.
Beautiful.
And our final crater, Chicard, tucked down in the southwest quadrant of the moon. The claim is 227 kilometers in diameter, which puts it in the running for being one of the largest craters on the near side of the moon. Of course, it is so close to the limb that it's highly foreshortened. But the curiosity of it for me is how it is so completely filled up with basalt. This isn't all infilled by debris thrown from a basin impact. This is actual basalt. It has been flooded from within by lavas, and if it were a little bit more centrally located, I am betting that it would have a legacy name of Mare Chicard, or whatever name they would apply to it. But it's classified as a crater by just history and time. So one of the largest craters on the near side of the moon. Very easy to find because it's uh, so dark and contrasting because of all of the basalt within it. I do not have an explanation for the white streak across the middle. It does not look like a crater ray. It is a different color basalt, and it's not unusual to find multi-hued basalts on the moon. The titanium content of the basalt will change the hue of it. So I'm thinking this is just multiple lava flows over a period of time where the composition of the chemistry of the lava that came up changed. So we end up with a different color. So moving on to my final slide, I always like to end things with this because I love our kitties, and you don't see Tinker sometimes crawling around on my lap while I'm trying to talk, get on the keyboard, and do nasty things. But anyway, there's much to live on the moon, and I consider the moon to be my playground, and I like you to come join me on my playground. So pay attention to the moon. There's lovely things in the sky, and granted, sometimes you can't see them if that bright moon is out there, but the moon is something you can see from the city. As you can see it from your urban backyard, the moon laughs at light pollution. So when you can't get out to your dark sky site, take your telescope out anyway. Look
That's
at the
right.
moon, become friends with it. There's marvelous geology there to be examined and study how things work on the moon by just look at who overlays who. The youngest ones are on top, the oldest ones are on the bottom. So lots to play with here. So I've enjoyed chatting with you about this, and I hope you've learned a little bit.
Yeah, and we always do, Robert. That's
Thank
wonderful.
you. I wanted to add my
Yeah.
thanks to Robert as well. I think that was really very terrific. I really did enjoy that.
Well,
And it really
thank you.
reminded me of lovely nursery rhyme. Lady Moon, where are you roving? Where are you roving? O'er the sea, o'er the sea. Lady Moon, who are you loving? All that love me, all that love me. I first read that in Starlight Nights, and it's a beautiful, beautiful, moving nursery rhyme. Also, I wanted to point out that your emphasis on Clavius really got to me, because to me, Clavius became famous as the site of the, as I'm sure you all know by now, of the site of the moon base that appeared in Arthur C. Clarke's
2001.
Yeah,
1.
2001. Yep.
And but you really pointed out how Clavius and Tycho are so related. With the
Yeah,
Tycho.
they're neighbors. They're neighbors, and of course the 2001 the Tycho Magnetic Anomaly one, just a hopscotch north of Clavius Base, where they dug it up, and interesting things happened.
Well, yeah. Anyway, thank you so much. Thank you so much, Robert. It really was wonderful. I really enjoyed that.
Yeah,
Thank you.
you.
Look forward
Yeah.
to next time.
Our audience had some comments here. Mark Drexler, watching on YouTube, says, one of the big reasons I enjoy the Global Star Party is Mr. Robert Reeves and his presentations. So,
Well,
yeah, and
thank you,
I'm
sir.
sure he's
I
speaking for a lot
appreciate
of
it.
people. Yeah, that's
I
great.
do appreciate that.
Yeah. John Ray says, my daughter presented me, he's watching on Facebook, my daughter presented me with Robert's book, Exploring the Moon, for Christmas, and I'm enjoying it. Many thanks.
I'm very pleased. Thank you.
Yeah. A question. This is from Fenord Ruby. Okay, if I got that right, if I ruined it, I'm sorry. Is it true that the moon is cooling and this causes earthquakes and wrinkles on its surface?
Well, it's slowly shrinking. Yes, the moon. Well, all of the planets are cooling. The moon started off molten uh, about 4.5 billion years ago, and finally its surface solidified and was able to record impacts that we see today. But the interior was hot, as evidenced by volcanism, and it has cooled down to the point where, in about the past billion years, the volcanism has stopped. And like I said, Tinker is trying to be mischievous here and march all over the keyboard. It cooled down and volcanism has essentially ceased. But it wouldn't surprise me if the interior, the core of the moon, was still warm and mushy. But as the world, or the planet, the moon itself, does continue to cool down, there is shrinkage, and of course tidal action between the Earth and the moon. The gravitational pull kind of shakes things up a little bit, and things settle and quiver and shake and tamp themselves down. So of course, the continuous impacts also create seismic shaking, which settle things down as well. So it's a constant process where there's change going on all the time, but not at such a rate where you can look up to the moon and say, "Oh my God, that's different than last night." We wish we would see something bright and flashy like that, but the time scale between them are many, many, many human lifetimes.
Yes. Okay. Well, Robert, thank you so much. And I think at this time, David and I will close out the 141st Global Star Party. So you have a good night, Robert, and we look forward to you next time. Take care.
Very good. Thank you.
Yep.
Bye-bye.
Okay. So, David, what did you think of the 141st Global Star Party?
I enjoyed it. I think you need to get someone else to do quotes at the beginning, because the quotes are, I'm working on a book right now where I'm taking all of the poetical quotations that I've done over the years and I'm
Yes.
arranging into a book. And when I start selling that book, you're not going to want to hear me anymore.
Oh, I think they'll still want to hear your
Okay.
voice giving those quotes and poems, and that's you bring them to life, and you bring them into the context of astronomy, especially a lot of the Shakespeare quotes and stuff. And we love your thoughts. We love the way your delivery, even when you sing, it's awesome. So really love it, and I know the audience does too.
Oh, thanks, Scott.
We're getting John Ray says, "Thank you, Scott and David. Another great Global Star Party. Looking forward to the next." And with that, we want to thank our audience. We want to thank all of our presenters. And we will be working on the next Global Star Party. And I'll get the theme from David. And we will we'll move forward. So keep looking up. And until that time, have a great night. Take care.
Okay.
Good
Bye,
night.
everybody. Good day, everyone. This is David Levy. That's me. And I am holding the original Discovery films of our most important comet, Comet Shoemaker-Levy 9. These films were taken on the 23rd of March, 1993. Carolyn discovered the comet on these films 2 days later. And about 16 months after that, all of the fragments of this comet collided with Jupiter, giving humanity its first view of what happens when a comet hits a planet. And one of the exciting things about this is that when comets hit planets, they don't just drop dust. They also drop organic materials, carbon, hydrogen, oxygen, and nitrogen, which eventually turn into proteins, amino acids, RNA, and finally, on one magic day, DNA. Comet impacts are really the first step in the origin of life. I'd like to invite all of you to come to the next Global Star Party. They are run by Scott Roberts of Explore Scientific and me. We co-host this program, and it's usually done on Tuesdays, and usually at 6 o'clock or so Central Time. And so I hope to see you all there. My name is David Levy, and I hope to see you all at the very next Global Star Party. Thank you.